Un, dos, un, dos, un, dos. Ahí está. Uno, dos, un, dos.
Hola, sí. ¿Se escucha? ¿Se escucha bien? Uno, dos. Dubi, dubi, du. Ok. Se escucha. ¿Quién habló? ¿Por qué no se escucha? ¿O sí se escucha? ¿Se escucha bien? ¿Ah? Si puedo hablar, sí. De hecho, en general me piden lo contrario. ¿No se escucha? ¿No se conecta? ¿Tenemos un tema técnico que resolver? Sí. Allá. Supongo que todos conocemos a Murphy. Ah, sí, sí. ¿Se escucha con delay? Sí, eso. ¿Se escucha con...? Solo que llega un poquito tarde el audio, pero se escucha bien. Perfecto. Sí. Bueno, muy buenos días a todas, a todos. Gracias por tenerlos hoy día con nosotros aquí en nuestra sede de Vitacura de la Universidad Adolfo Ibáñez. Déjenme partir presentándome. Mi nombre es Arturo Alba. Yo soy el director de Ingeniería Civil e Industrial de la Facultad de Ingeniería y Ciencia. Y tengo el placer hoy día de introducir este seminario, ¿no?, de Ingeniería de Sistemas basadas en modelos para innovar en la industria aeroespacial. Nos acompañan el día de hoy el señor Jason Wilson, que es director de Ingeniería de Sistemas de Dassault Systems, justamente especialista en Ingeniería de Sistemas basada en modelos, quien es el expositor principal que nos acompañará el día de hoy. Nos acompaña también y se nos va a incorporar más tarde el general Luis Sáenz de la FACH, que es director nacional espacial y jefe del proyecto de Sistema Nacional Satelital de Chile. Nos acompaña también hoy día don Cristian Alfaro, gerente para el Cono Sur de Dassault Systems, y don Ricardo Ramos, gerente general de Solaer Ingeniería, para quienes pido un aplauso para que vayamos. Muy bien. Muchas gracias. Para mí es doblemente grato el poder estar con ustedes hoy, porque iniciamos la celebración de los 35 años de Ingeniería en la Universidad Adolfo Ibáñez. Cuando la universidad parte, ¿no?, hace más de 65 años, como una escuela de negocios, ¿no?, en Valparaíso, buscando fundamentalmente promover las capacidades de administración en los emprendedores que en esa época se hacían, no se formaban. Pues obviamente han pasado muchos años. Hoy día, con mucho orgullo, podemos decir que no solamente nos encontramos en la tercera posición de las ingenierías a nivel nacional, sino que además estamos en una posición destacada en los distintos rankings. De hecho, somos la primera universidad joven de menos de 50 años en la formación de ingenieros de Chile. Al día de hoy tenemos 7 carreras. De hecho, con orgullo también podemos decir que en este minuto, en paralelo, en Peñalolén, en nuestra sede de Peñalolén, junto con el rector y el decano, estamos firmando, y justamente con el general Luis Sáenz, ¿verdad?, esta alianza que hemos formado para poder desarrollar la carrera de Ingeniería Aeronáutica, que durante los próximos 7 años vamos a estar acompañándonos en la formación de ingenieros, ¿verdad?, pilotos y las distintas ramas, ¿no?, en la Fuerza Aérea de Chile. Tuve la oportunidad hace algunas semanas también de estar en el APA ahí viendo las infraestructuras, laboratorios, un poco compenetrarnos con lo que vamos a estar desarrollando. La universidad y particularmente la Facultad de Ingeniería y Ciencias tiene un compromiso fundamental con la sostenibilidad y por lo tanto con usar las ciencias, las matemáticas, las tecnologías, el arte, con el objeto de hacer una transformación profunda en la forma en que entendemos el mundo y en la forma en que balanceamos la capacidad de generación de valor económico, social y medioambiental. Cuando uno piensa, ¿no?, en la transformación que vivimos durante el siglo pasado, ¿no?, las revoluciones industriales eran fundamentalmente extractivas y el objetivo fundamental es la capacidad de aumentar la productividad, la capacidad de generar mayores recursos, la capacidad de integrar un mundo globalizado. Sin embargo, no teníamos una conciencia suficiente sobre el impacto que estábamos generando en el medio ambiente, sobre las desigualdades sociales que esto también generaba, y por lo tanto el foco era fundamentalmente económico. Ese paradigma ya no sirve, no nos permite un desarrollo, ¿verdad?, integral, y no solamente la ONU, el Banco Mundial, distintas organizaciones hemos ido evolucionando a entender la importancia central de generar este triple valor simultáneamente. Valor económico, social y medioambiental. Y hablamos de temas como la inclusión, hablamos, ¿no?, de temas con la preocupación del medio ambiente, y es un desafío desde todo punto de vista esta capacidad de integrar, ¿no?, estas distintas visiones. Y justamente es aquí, desde el plan satelital que vamos a tener, liderado por la FACH, que nos va a permitir tener una comprensión más amplia del entorno en el que nos encontramos, el impacto climático y cómo esto se relaciona con el desarrollo de la industria, con el desarrollo urbanístico, el impacto en la agricultura y en distintas industrias. Así que, dado eso, vemos una comunión de intereses fundamental. Y para poder resolver estos grandes desafíos que tenemos por delante, evidentemente que se necesitan distintas disciplinas, entre ellos la ingeniería, que es la razón por la que hoy día tenemos justamente una presentación de Ingeniería de Sistemas basados en modelos. Cómo somos capaces de articular, ¿no?, una arquitectura que nos permita entender los distintos desafíos técnicos y adaptativos que tenemos por delante. Evidentemente desarrollar tecnología, pero una tecnología con propósito. Ser capaces de articular un ecosistema en un ámbito tecnológico, pero también influir e integrar a los distintos tomadores de decisiones, a la sociedad, entre otros, al mundo del Estado, al mundo privado. Por eso quisiéramos agradecer nuevamente a nuestros asistentes. Quiero dejarle la palabra a Cristian Alfaro para que nos presente la agenda del día de hoy y después continuaremos con Jason Wilson. Así que a todos ustedes, muchas gracias y bienvenidos a esta que es su casa, la Universidad Adolfo Ibáñez.
Después de esas palabras ya no sé qué decir después de esa introducción. Muy buenos días a todos. Agradecerles que estén acá con nosotros, agradecerle a la Universidad Adolfo Ibáñez que nos está hospedando hoy día en esta presentación, en nombre de Arturo Alba. Agradecer también a la Fuerza Aérea, en particular al general Luis Felipe Sáez, como ya lo comentaste, está justamente en una actividad en otra sede de la universidad. Agradecer también al coronel Contreras, que es el director nacional espacial. Agradecer especialmente a Isabel y a Juan Pablo por toda la organización. Mi nombre es Cristian, déjeme avanzar. Mi nombre es Cristian Alfaro, soy representante comercial para Andina Sur o Cono Sur. Estoy basado acá en Chile. Quiero presentarles primero la agenda y después les voy a contar en un par de minutos quiénes somos, quiénes Dassault Systems. La agenda que tenemos para el día de hoy, bueno, está separada en dos bloques. La primera parte va a ser un tema introductorio a lo que significa Model Based System Engineering, que lo va a dictar Jason. Tenemos un pequeño break en el cual después se va a incorporar el general Sáez, nos va a acompañar con algunas palabras al inicio del segundo bloque para terminar con algunos casos de referencia en la industria aeroespacial. Me gustaría comenzar contando quién es Dassault Systems. Dassault Systems nace en la década de los 80. Somos una empresa francesa, nuestra casa matriz está en París. Hoy día ya somos alrededor de 24.000 personas alrededor del mundo, en 142 países. Somos una empresa científica, tenemos un componente de investigación y desarrollo muy grande. Ya hoy día tenemos 79 laboratorios de investigación y desarrollo alrededor del mundo. Hasta el final del año 2023 eran 76 laboratorios. Este año hemos creado 3 nuevos laboratorios y así todo año tras año. Tenemos una salud financiera bastante buena. El último informe financiero del año 2023 tuvimos ingresos por 6.000 millones de euros con un margen operacional de un 32%. ¿Y por qué lo menciono ese margen operacional? Porque mucho de esto lo reinvertimos en desarrollar nuestros productos, lo invertimos, reinvertimos en todo lo que son los laboratorios de investigación y desarrollo, y lo reinvertimos también adquiriendo compañías que nosotros vemos que tienen un gran potencial y los incorporamos a nuestro ecosistema. Nuestra estrategia comercial también incorpora a partners alrededor del mundo, que nos permite tener una mayor cobertura, una mayor capilaridad de poder llegar a nuestros clientes. Hoy día contamos con más de 14.000 partners que son del ámbito académico y del ámbito comercial. Tenemos una fuerte componente académica también, que nos permite también llegar a niveles de universidades de pre y posgrado. Nuestra presencia, como ya lo comenté, nuestra casa matriz o campus está en París. Sin embargo, tenemos también dos headquarters adicionales. Uno está en Boston para Américas y uno en Shanghái para lo que es Asia-Pacífico. Y nuestra presencia en LATAM. Hoy día tenemos nosotros oficinas. México es parte de la geografía de Norteamérica. Así cuando hablo de Latinoamérica, hablo principalmente de Centroamérica y de Sudamérica. Tenemos nuestras oficinas principales en Brasil, en Sao Paulo. Tenemos 3 oficinas en Brasil. Tenemos nuestra oficina en Chile. Nosotros estamos ubicados en el edificio Titanium, acá en Santiago. Y tenemos unas oficinas también en Colombia, que son oficinas un poquito más de soporte técnico. Esa es nuestra presencia hoy día en LATAM. Tenemos más de 15.000 clientes hoy día activos. Tenemos un ecosistema de más de 35 partners que nos ayudan a tener esta cobertura en países donde no estamos, en países que no está DASO. Tenemos partners hoy día que están haciendo esta cobertura comercial y en total ya somos alrededor de 200 personas en Latinoamérica. Este slide me gusta mucho porque refleja nuestra creencia, refleja nuestro negocio, nuestra visión, que es extender el mundo virtual al revés, extender el mundo real hacia el mundo virtual. Y esto, explicado en palabras simples, es cómo digitalizar, llevar a Virtual Twin todo tipo de implementación o proyecto. Tengo un ejemplo que siempre utilizo, que es el ejemplo automotriz, del mundo automotriz, que me imagino que muchos de ustedes han visto que son los crash tests, ¿cierto? Cuando empiezan a hacer las pruebas, digamos, de algún modelo nuevo, donde empiezan a hacer estas pruebas con un dummy, ¿cierto? Adentro, se abren los airbags, empieza a deformar la carrocería. Todo esto, años atrás, se hacían pruebas físicas. Eso significaba costo, ¿cierto? De lo que significaba romper un auto en cada prueba y tiempo. Incluso quizá el tiempo era peor que el costo, porque después todo lo que era el estudio de cuando se formaba este vehículo significaba mucho tiempo. Todo esto hoy en día se hace a nivel virtual. Uno lo lleva todo esto, hace todas las pruebas en un ambiente virtual donde puede uno tener pruebas de acústica, uno maneja la curvatura del vidrio del auto para tener mejor, digamos, que el viento pase sin tener tanto roce. Todo esto, este mundo que lo grafico en este aspecto del mundo automotriz, es lo que nosotros realizamos con todas nuestras suites de productos, que es llevar a un mundo virtual un mundo real. Como ya comenté, nosotros partimos en la década de los 80, somos un spin-off de Dassault Aviación. Dassault Aviación creó un software de CAD para desarrollar y crear aviones. Ese software de desarrollo propio fue tan exitoso que se empezó a comercializar en la década de los 80 y aparece Dassault Systems, que somos nosotros, y empezamos a crear toda una suite de productos, partiendo de todo lo que es el diseño 3D, todo lo que son maquetas digitales, todo lo que es simulación, hasta llegar a lo que es el Virtual Twins al día de hoy. Esta es nuestra plataforma. Es un concepto que nosotros utilizamos, es un compás, nosotros denominamos compás, un concepto que agrupa todas las soluciones que hoy día tiene Dassault. Soluciones tanto de colaboración, soluciones de modelamiento, soluciones de simulación, realidad virtual y soluciones de todo lo que es analítica. Esta, que es la siguiente slide, la vuelvo a mostrar, pero haciendo un zoom, ¿cierto? En el lado izquierdo de la pantalla, ustedes pueden ver todas nuestras aplicaciones. nuestros productos, ya más detallados. Cada cajita que aparece ahí de diferentes colores, dentro de esa cajita hay una solución de basado con cientos de aplicaciones que hay en cada una de ellas. Y ahí hay un detalle, hay algunas más conocidas que otras, que probablemente ustedes han escuchado. Tenemos CATIA es una solución que hoy día están utilizando en ENAER, por ejemplo, son soluciones que están usando hace bastante tiempo. SolidWorks es otra solución que es bastante conocida, ¿cierto? Y hay otras menos conocidas que son más de nicho, más específicas para la minería. Nosotros tenemos soluciones para la minería, tenemos una amplia presencia en Chile y Perú en la minería con nuestro software. Tenemos software de simulación, como lo comenté anteriormente, Abacus, que es el branding, que también es bastante conocido por sí mismo, y todo lo que son soluciones de analítica. En el lado derecho de la presentación pueden ver las industrias donde nosotros hoy día estamos trabajando. Yo diría que de esas dos industrias en Latinoamérica, nosotros para Latinoamérica es un mercado emergente. Nosotros estamos hoy día de los últimos 4 o 5 años invirtiendo y creciendo acá en Latinoamérica, invirtiendo en personas, invirtiendo en presencia. Uno de los motivos por que Jason está con nosotros es eso, parte de la inversión de crecimiento en la región. Tenemos 4 industrias, yo diría que foco en nuestra región. Aeroespacial y defensa, sin duda, una de las principales que tenemos, tanto en Chile como en Perú, como en Colombia, como en Argentina, que las principales empresas aeroespaciales están trabajando con nosotros y algunos startups satelitales también. El mundo automotriz, si bien es cierto, en nuestra región no existen marcas así propias, pues están en otras geografías. Hay muchos autopartistas que hacen partes y piezas para automóviles y esos son también nuestros clientes. Y todo lo que es la industria de equipos, de fabricación de equipos, también de diferentes, digamos, rubros. Y por último también todo lo que es marina. Nosotros estamos trabajando hoy día con la marina en unos proyectos con ellos también. Y también es parte de nuestro foco en la región. Este es un resumen de algunos logos con los cuales trabajamos en el mundo aeroespacial y de defensa. Son logos que nos permiten que sean públicos, ¿cierto? Y solo para que tengan una pequeña visión con quiénes son nuestros clientes alrededor del mundo. Probablemente Jason va a profundizar acá con alguno de ellos y con algunos casos de referencia, pero solo quería que se quedaran con esta última slide, que es la última, para que vean cómo estamos nosotros trabajando en el ámbito aeroespacial, aeronáutico, tanto en el espacio como a nivel terreno. Con esto ya doy el paso a Jason Wilson, que va a continuar con la agenda y nos encontramos en el break. Les quiero pedir un favor. Pregunten lo que sea. Yo creo que aprovechemos desde los acrónimos, desde qué significa una sigla, hasta alguna otra pregunta. Yo quiero aprovechar la visita. Jason se va el jueves por la noche. Vamos a tener algunas reuniones con algunos de ustedes en estos días. Sin embargo, todas las dudas que aparezcan durante la presentación, les pido que las hagan. ¿Ok? Jason, the floor is all yours.
Thank you. I appreciate it. Well, good morning. So, only 2 rules today besides falling asleep while I talk. One is if you have a question, ask it right away. One, I don't mind being interrupted because I'm here for you. You asked me to be here. I'm here to help. I want you to understand that what we talk about today can help you in your career and where you want to go. Number 2, what do you think number 2 is? If I'm asking you to talk and ask questions, what's the rule number 2? I don't know what you said, so someone translate. So rule number 2 is if you don't know what I said or have a question and you don't want to speak in English, feel free and the team will help me understand what you want because, again, I'm here for you. All right? All right, so unfortunately, I'll give my own introduction. I'm Jason Wilson. I lead the CATIA systems engineering team for the Americas. That's why I'm here. I am also part of the headquarters in France, but I live in America. I've been doing this for quite some time. I've had a fun career with model-based systems engineering or engineering itself. I started as a small person trying to learn what Java was and what the importance of building your own business was and understanding how modeling can take it to another level. And then I decided sports was a lot more fun for me, and baseball took me in a totally different direction. And then at one point I said I needed to come back. And I came back and said, this is a lot of fun. Let's make a career out of it. How do you do that? With will, with desire, and a willing to learn something new every day will get you where do you want to go. From experience, I will tell you, if you put yourself in your shoes and say, if I learn something new every day, I will be a better person. I promise it's working. Okay? I do have a great family, a wife and 2 awesome kids. Hopefully you do too. They actually are the motivation of what keeps me going from a day-to-day basis. I promise you. It's a lot of fun to ensure what I do helps them get what they want. And they want a lot. Does anyone else feel that their significant other wants a lot? Or we want to give them everything? So let's get into what today is. Today is about MBSE and understanding it from any level that you want. I'll go from as high to as low as you need, but I'm going to stay from a high, mid to high level. Okay? Most of my career has been in aerospace and defense. However, I'm not standing here in front of you without some other stories that will come out during this presentation. Okay? So, how do we do that? Let's pause. Go back. Let's see if we can hear it. We'll start with the video. So interesting, eh? What did you think about that? So what are, let's say, 3 things that stood out throughout the video? There was teamwork? Oh, whoa. Maybe at the end, right? At the end. Okay, so that's what you remember, at the end. So we'll get there. I'm going to talk about how collaboration makes the wheel turn. All right, so collaboration was one that was missing. What was another? Same language or same idea. They did whatever they wanted, right? Okay, that's 2. We're 2 for 2 in a row. Okay, so 2.5. What's one more? I'll give it to you. It's 2.5. No directions, no, everyone's using different tools, nothing the same, right? So who's an engineer? Okay, I'm going to put my hand down. I'll raise it when I need to, right? So who's an engineer one more time? There's like 8 of you, 9 of you? All right, so who is non-engineer? We'll just make it easy. Okay, see how my hand stayed down both times? I'm not an engineer by trade. I'm a wannabe engineer. But does that make me a non-systems engineer? So we'll talk about this at the end of what makes a systems engineer so successful and what you can do to get there utilizing technology or growth and how we can overcome these setbacks that you saw. I talk about systems engineering because in my experience within the programs that I've been part of, systems engineers, if you're the chief systems engineer, you are on that program until what? You die? You get fired? You die? You own the program from day one, right? Okay, so if you die, this is fun, right? I want you to laugh. You quit or get fired. where you decide to leave for more money, or you just said the program's not going to win, so I'm leaving. Good shit, bye-bye. Does anyone disagree with that from a systems engineering perspective? Right? You own the program. You are the master. So I like the term that you're a puppet master. Why? Because you have the ability to make sure that everything that goes into that program is coming together. So let's talk about the coming together of what makes systems engineering on the left-hand side so important. But let's not talk about the importance of what I think systems engineering is. Who has heard of the logo that you see in COSI? 2, 3. Okay, so in COSI is the International Council for Systems Engineering. You want to be a systems engineer? I highly encourage you to look into it. If you want to be part of the systems engineering ecosystem, I highly encourage you to be part of it. Why? Because it helps you within your life cycle management, and how life cycle management helps you within the program or projects that you are doing. But then you would ask me, the question is, what's on the right-hand side? Why are we talking about model-based systems engineering? Who in the room understands what model-based systems engineering is? Whoa. I have a hard day. Okay, that's okay. That's going to be a lot more fun. All right, so does anyone have a question about the definition of what model-based systems engineering is before I give you my answer? So you all can read it. Do we want to translate it or no? No? You good? Okay. So I come from the tool, right? I'm part of Dassault Systems. We are a tool vendor. I think modeling is, I'll explain it how I talk to my children, because they always ask me why I live on a plane. I live on a plane. I fly a lot, right? I love being in front of the customer, and I want to make sure that you understand what you're getting into. So who's used Visio? Who uses PowerPoint to express knowledge of the project you're doing? Let's change it up. PowerPoint? No? Oh, yeah. Okay. Feedback helps me help you. Okay? I promise. Do not be afraid to ask questions. If you are afraid to ask questions, you're in the wrong presentation, because it's a long time you're going to listen to me today. Okay? So within that, so everybody knows how to draw a box and a box and have it connected, correct? And we want to know what information and what connections and what potential electricity or data goes between one box and another, right? Boxes and lines. It's an insult, and I'm not here to offend any engineering. But when we look at it from a high level, and we say, okay, we're drawing boxes and lines, and we're at a 0D level, not a 3D level, which is really cool about CAD of CATIA, but we're at a 0D level, we want to make sure that we're architecting a system. Do you think in the video we architected anything? No, wasn't possible. A lot of people look at systems engineering and model-based systems engineering as a blueprint. I would say I totally agree with the story. It's more fun for this kind of audience who have not heard about systems engineering from a model-based perspective. Everybody knows how to read a blueprint? No? You don't know how to read a blueprint? That's okay. So a blueprint in meaning pictorial directions on how you want to build something. Okay. If MBSE is almost the same thing of you're building a diagram that allows you to express what the system could do, should do, will do, and you're meeting the requirements of your stakeholders or the requirements of the system, you are now doing model-based systems engineering. You can do it from software engineering too, or we can go the opposite way and we can talk about enterprise architecture, which will be the next talk. And then I'll really confuse you. Okay? Is everybody clear on what model-based systems engineering is now? You guys have made this really fun so far. And then what is your definition of classic systems engineering? Yeah, there's not much difference. The difference between model-based, you will see in about 6 slides of what you need to do to ensure the capabilities of the MBSE style or method meets the needs of you as the engineer and the engineering team. And it takes three major things for you to do model-based engineering effectively. Does that make sense? I'll explain it, I promise. That's a very good question. So I really want to look at where it's used. So we already know it's going to be potentially used here in the Chilean Air Force, right? We know that it's the #1 solution for the US DoD and US military. Is it used anywhere else? No? Okay, so I can tell you, I am not standing here today without healthcare, without automotive, without tractors, talk about that later, and of course the US DoD. There is not an industry that I have not spoken about when it comes to this type of solution that you can benefit from. I've even worked with engineers that have modeled their home interactions and functions so that they can help learn this language to ensure that it's being done right from a functional level. Everybody would understand what we mean by functional level? I lift my arm, the human, the brain, so I would have an activity diagram to do that, and the arm lifted, correct? So who has a smartphone? I don't have mine on me. Do you think that's hard to build? Do you feel that it's complex? What about this guy, right? I got one of those. What about this? Is this hard? Kind of, right? Small amounts of code, but there's electronic to ensure signal, right? I haven't even shown off how cool this thing is, right? All I'm doing is pressing the button to make it go forward. But it is complex. It has to charge. It has to last so long. It needs to be a presentation, and then it needs to have this cool little feature that I can zoom in without paying attention. Huh? And it can change. I can make it a laser pointer. I can do all these things. To me, that's difficult. Why is that? Why could that be complex? So if I'm the systems engineer, why is it complex? Yeah, instructions. No. Absolutely. I agreed wholeheartedly. And I think what I want to say is just because the device is small does not mean it's not complex. So if we're talking about complexity, we have to understand our audience or where it comes from. I promise you, everyone on this board from an industry perspective is using our tool somewhere. A solution of MBSE. Is this about the tool or is this about your knowledge today? I promise you, I come from a very neutral type of thing. Yes, Dassault Systems pays my paycheck, and I'm very proud of that. But I come to you from an INCOSE perspective, and a group called the OMG, the Object Management Group, which we write the standards. I'm part of working groups there. So I come to you from a very neutral perspective, okay? If you feel that I'm saying there's too much Dassault, someone raise their hand and tell me, and I'll calm it down, okay? But if we look at this board, who's the winner? Aerospace and defense, right? Okay. But I did promise you that we use it in other areas, right? I can tell you automotive is very close to aerospace and defense, especially in Europe. They're growing rapidly. But I told you that I'm not standing here unless it was because of a car company, right? So we know there's 3 major car companies in the US, right? Name one of them. Ford. Name another. General Motors. Can we get all 3? No, that's aerospace and defense. Jeep. Yeah, so it's Jeep, Dodge, Ram, right? Chrysler, right? Chrysler is the ownership, okay. So I'm not standing here in front of you unless we won Ford. Ford started with 2 engineers that had a dream to get model-based inside of Ford. And then it became 5 engineers in propulsion, engine design, and then they bought a server, and IT wouldn't do anything with it, so it became someone's desk. They literally had a server for all of their models at their desk for 5 years. It was awesome. It was great. It was so cool. Going there and knowing that IT did not care about the solution, but they were making great waves in their growth of adopting a new fundamental capability within R&D of a new engine was awesome. And then it became, we need to look at FMEA, functional risk analysis and capabilities, right? Everybody likes risk. Does everyone take risks here? Yes? Right? I hope everyone says yes, because you all drove here today. It's a risk. Well, in the US, it's a risk too, I promise. Okay? So if we talk about the complexity of where things come from, we talked about this as high tech, right? We talk about Ford. We talk about you guys flying jets or putting things in space. How complex are we talking about? Let's look at the evolution of lines of code to where we are today. Now, this presentation's a little older. It comes from a keynote I did 6 years ago, 7 years ago, but it's still relevant today. Now, you're going to tell me, and I had to prove it to the team yesterday, that we landed on the moon with 145,000 lines of code. It's a true statement. That's what it was. It's awesome, right? That hardware, the capabilities, the way to land, those kinds of things. But then look at the progression. So then again, I ask, who has a computer? So you have an iPad. How many lines of code are in the iPad? It's not up here because it's too many, right? Okay. So I drive a Ford F-150, and I'm very proud of my Ford F-150. Okay? Do you actually think I drive a Ford F-150? Yeah? I mean, I have a white one, and this is gray. But yes, I drive it. But you actually think it's a car or a truck. Okay. I have 150 million lines of code in my truck. I have 28 different computers that are ensuring the truck is always doing what I tell it to do. I'm not driving, the truck is driving. I'm driving a computer. Okay? Take a step back. 5 minutes ago, I asked you if you knew what a box, and a line was, right? Now I'm telling you to think deep into the vehicle you drive today. How many different interactions are you doing when you press the on button? Yes? Can you put them all on the board? No. So the complexity is getting too hard, right? It should be a lot of them, right? But is it too much for the human to ingest at one time? Yes. So why would we not use software to help understand where everything is going from one box to one box? It could be. Unless you become a power user and it's very fast. I've been doing this since I was, all right, so I've been at Dassault for 15 years. I started modeling for real my senior year of high school, which was 2001, 2002. I met the No Magic team at the Java 1 conference in San Francisco in 1999. And I heard about this cool little consulting / UML tool when I started learning Java when it was 1997-ish. So I'm old. The gray hair shows, right? Okay, it's okay. That doesn't mean that modeling makes you old, but it does show that modeling helps you overcome what? Complexity, potential, right? Amounts of data that we need to consume. Who uses AI? No one? Yes, so one. Okay, so I'm learning too, right? ChatGPT, making sure that when I write emails to executives, it's a good email, not a bad email. Okay. That's when I use it. I use it the most to say, hey, is this something that they should read, right? At Dassault, internally, we have our own AI, so I can check it against that, okay? I would say it's okay. So let me take one more step back so that I can make sure everybody's on the same page. Who knows how to draw a picture? Yeah, draw a picture. What about a picture like this? That's where we started in life, right? But we understand what the meaning is, right? We're gonna go kill something, right? Or we're going to shoot something down or put something in space. Or I'm going to drive from one side to the other and go find my food, right? But did we learn how to do this better? I think we did. More pictures, more meaning, more understanding. The evolution grows. So you're seeing the value of a picture. So what about when we start writing about the picture and we start documenting the system? See where I'm going with this? Am I getting close? All right, but I'm not that close because documents become overwhelming. When you get a 500-page schematic, do you go straight to page 400 and say, I'm done? Do you start on page 1? No. You start at least on page 10 because the first 10 pages are the index and stuff we don't care about. Just plain. So when we go there, then when the computer came and our life got easy, right? We scanned our documents, we understood, we process. So we look at how process helps us get to where we want to go now. I didn't talk about a tool. I talked about an evolution of engineering. We didn't even know we were engineers back then. We didn't know what we were doing. We were executing to solve the problem. I need to eat. One of the things that makes effective engineers, especially on the system side, is understand what the problem is. Understand the mission. Ask questions and be effective. That's what makes the difference between typical engineering and model-based systems engineering. Systems engineering, no, has not changed. What we've now done is we've added a method to get rid of documents and to look at it to bring everybody under the umbrella to understand what's going on. Who's a requirements engineer? Who writes requirements? One? Okay, I can put my hand up now. See? First time. Voila. I finally get to put my hand up because I can write a requirement. I write requirements with my team. I don't task them. I say, hey, we have this problem. Here are the requirements. Add the requirements, fix my requirements, and let's go build it together. What did I do? I didn't send them a memo. I showed them the value of this. So when we talk about engineering and we talk about requirements and I hand you this pretty piece of paper, is it helpful? Maybe. What about Excel? Has everyone heard of Excel? Or Google Sheets, right? Everyone knows that Excel is the #1 requirements tool in the world. Anyone want to disagree? No? Oh. What's #2? You guys know the software tool industry? We'll see really quickly. What's the #2 requirements tool in the world? Word? No. PowerPoint? Like #6. So #2 is IBM Doors. Very good tool. Love it. Love the tool. It's awesome. IBM Doors for requirements engineering, change management of requirements. Awesome. What's #3? Okay. I gotcha. CATIA Magic. #4 would be maybe JAMA or maybe FlipFum. We're probably fighting right now. So the CATIA tool, why I am here, what we'll talk about later. We're probably #3 or 4. JAMA is a web-based requirements tool. Why are requirements so important to systems engineering, but why are they so important to the engineering itself? You swore at me. I didn't swear at you yet. I hate the word traceability, but it's very important to systems engineering, yes, and I'll explain it later. Traceability is 1. 2 is requirements help. The stakeholder is going to tell you what the mission is in a very textual format, right? We shall fly for so long, the vehicle shall stop at this speed, must have 4 doors, must be commercial ready, so on and so forth, right? Basic high-level requirements that your bosses tell you about. So when we bring it all together, it helps us what? Collaborate. That is why systems engineering is important today. We're improving on so many things. I'm going to go through the 5 big things in just a second. But when we talk about taking an engineering domain and bringing it together, we're talking about overcoming complexity, understanding cost and time. We'll get into it. But really how an engineer or engineering team can work together with everybody. As a systems engineer, I'm not a specialist in code. I'm not a specialist in hardware. I'm not a specialist in requirements. I'm not a specialist in anything except for what? What I say earlier. I'm a puppet master. What am I a puppet master of? Data, collaboration, ensuring that my stakeholder, who's my number one stakeholder as a chief systems engineer? It's not the boss. It's not the boss. Customer, and there's two. It's the customer and the PM, right? The project manager. I don't put them up there because they're not that important. This is about systems engineering. Okay? But when we bring this all together, your job gets easier, I promise. We want the job to be easy, right? It can't be too hard. It'll take too long. We'll talk about time and cost later. But let's talk about it now. Why not? The world is getting expensive. I have 2 kids. I know firsthand. Okay? But I can tell you this, and I'll prove it to you later, that systems engineering might take just a little bit longer than your typical engineering you're doing today. But I promise you, you'll save time and money, even though your first iteration will take a little longer. So, I asked the customer, actually it's a customer question I ask all the time, and I say, Mr. Customer, how long did it take you to build your as-is today? Their typical response, oh, it took me 12 months, 24 months, 48 months, voila. And I said, okay, when you got to 2B, or you're doing your 2B, how long is it going to take you? Most of them say, oh, 14, maybe 12 again, 18, because we're going to rewrite some sections and so on and so forth. And I said, oh, and if that's 2 years down and you're going to go 2 more, how long is it going to take you? Oh, same amount of time. So let's make it easy. 12, 12, and 12. Seriously? 12, 12, and 12? Are anybody used to that? No? It's always shorter? No. Okay, so in my experience with systems engineering, the first time you do systems engineering, I'm going to use the 12-month method. So if I'm saying we're going to do systems engineering together and we're going to use CATIA Magic to do it, I promise you it will take me, we'll keep the math simple, 15 months. I'm going to add 3. So that's my as is today. We're going to model your iPhone. And it's going to take us 15 months. Is that okay? Oh, okay. Not so much, right? So it's a little scope creep and adding 3 months, it's no big deal. Okay, that's fine. But what I say is we're going to get to a 2B, right? We're done. We're 15 months. Bosses are happy. We're making money. Or we're shipping and flying and doing whatever. New features. New function. I can do it in 12 months. Who's happy? Everybody. Nobody? Did you say nobody? Nobody's happy. I reduced it by 3 months. I increased the project from day 1 by 3, but to get to the 2B, all my new features, functions, technologies, languages, I can reduce it now by the 3 I gave you, I taught you. Well, let's go to version 3. Version 3, I can now do in 10 months. Probably less. I'm going to be very conservative. 10 months. How? Why? Because when doing it in the model, I get to reuse. I can do better trade studies. I can work with other engineers and make small changes and ensure those changes are done quicker, better, faster. Did that just save me time? Did it save me money? It cost me more money up front, but I saved my money in the longevity, correct? So when we look at that, it allows us to do the major thing of systems engineering, in my opinion, and that's why it's number 2 in this list, is collaborating. I just proved it to you. What was it? I talked to the hardware, I talked to software, I talked to my stakeholders, I brought them all in, and I showed them where we're at as the as-is project, and I showed them how we're going to get to do B faster, faster, faster. Are you willing to make that sacrifice, Mr. Customer? We have to ask her that question, but I have to prove it to you, right? And I have case studies that I will prove it to you. But collaboration is the key. Reuse is the key. When we look at this and how we're going to get there, we have to look at a transformational thought. Who's heard the term systems thinking? No. System thinking. Systems thinking is the ability to think outside the box. Okay? But bring it in and be faster with it, right? There's a couple different definitions of system thinking. That's how I think of it, right? I love systems thinking because it allows me to look at all the different things in front of me and I can say this works, this doesn't, no, move on. One of the greatest capabilities of being a systems engineer from day one, if we think about conceptual design, is I don't have to say that's the part number I'm going to use because I don't know yet. Does that make sense? In my logical design, am I still picking a part number? No. But I'm building the design. I'm ensuring it's working. That's the digital transformation. Within that transformation, I have to show agility. Now, I'm not talking about agile software. I'm talking about being agile with your teams. Making sure that you can talk with them at any point in time and say, what is going on here? This does not make sense. There's too much electricity. Let's simulate it. Let's understand. Are we okay with change? Is change good? At times, right? Why is change bad? It's a risk. But we have to manage risk. Can you manage risk? Yes, absolutely. Can you understand why risk is important? When to take it, when not to take it. We as humans can do that, right? Can the machine do it for us? No, but it can tell us probability. Math is king, right? We're engineers. When we think about where we want to go, the calculated risk is done for us, and it's up to us to say yes or no. Pass, fail. Yes? We agree? Oh, good. I'm connecting with you now. And we've been talking about complexity, but we have to manage it. Senior boss man, it's too hard. The technology is not there. We have to, as the systems engineer, we have to be willing to say, it's not possible. Can you do that in the way you do it today? No. The technology needs to help you grow. It needs to help you understand those calculated risks, and it needs to understand that you, as the human, can only do so much. So let's get to the last point in my understanding. So I've done a lot, right? I talked about Ford. We'll talk about John Deere later. I was very proud during my career, and we'll talk about it even further, is that I got to do some consulting with NASA and with JPL. We'll put JPL to the side. But you can find some NASA documentation about why bringing all of this together helped them reduce errors in their programs. They did this by utilizing MBSE, obviously, but looking at bringing in the architecture to tie back to the requirements for the word of traceability, right? It's king in systems, but it helped them find out that things weren't going to break downstream. When we think about engineering, we have what? Requirements, we have design, we have 3D, we have manufacturing, and then we out the door, right? As is process. So when we think about how all that comes together, what do we need to do? We need to ensure there's no errors during manufacturing, and if there are, how do we mitigate that, correct? I can tell you from the experiences that we've had that the companies that are adopting a model-based systems engineering framework or method or tool are being successful in up to, I'm going to be conservative with this number because I really don't believe it. The number in the paper is 80%. No. 60% I can live with. So I'm going to reduce the number of errors by 60% by adopting a method, a tool, and requirements inside of a model-based tool to get there. Is 60% significant for your programs? Okay? and you're going to say, Jason, prove it to me. I'll prove it. Okay? The one success that I would say, when we look at textual requirements as we're doing it today on paper, what's the number one problem? And I'm not telling you, you're going to tell me. What's the number one problem about doing textual requirements, whether it's in Excel or whatever? What's the problem with textual requirements? All requirements are textual. Don't think about the semantics of it. It's redundancy, right? You can have redundant requirements because why? We're human. We all speak differently. The vehicle shall stop at 50 miles an hour within so many feet, right? But if the vehicle is making a turn at 50 miles an hour, can that still be compliant? So now we have to look at turning radius. What happens if the owner puts a different size tire on the car? Does that change my requirement? Does that change my verification and validation suite? Should I plan for that? Yes, sir. Yep. Yes?
We start with the version requirement.
Mm-hmm.
And then we transform this version requirement to requirement to technical requirement.
Absolutely, yes.
And then we start to find the solution or try to find a solution that will matter and to the carry up between different systems.
Yes.
That's the problem.
Yes. Yeah. I'm going to show you a video that shows that. Exactly. Those processes become key. In our term, the reason I don't like the word traceability is because I'm part of the language within systems engineering called SysML. Anyone heard of SysML? SysML, SYSML, Systems Modeling Language. Okay, so systems modeling language is the boxes and lines and the functions and the requirements all coming together under one roof. Just like us. We're coming together, we're learning together. Okay? And within that, it allows for us to understand what the system is. If I understand my slides right, this is perfect. When we come to that, within your verification and validation suite, you can see on the screen, I can use a lot of different technologies, and I can bring a lot of different engineering players into my room, into my castle. And within that, I'm able to, in the Dassault terms, we federate the data under one tool, the 3D Experience platform, or in this case, we're going to talk about CATIA Magic, which is the systems engineering tool. Then we feed the 3D Experience platform with data. Okay? It's about the most tooling I'll talk for a little bit. But when we look at this and having everything come together, what is the cool picture right here in the middle? The other way, Jason. I have to be somewhat close, right? End-to-end traceability. Wow, you said it earlier. I could have quit right then, and then we would have flown me here for nothing. But I don't like the word traceability. Why? I'm based off the language, you don't know. The language has something called relationships. Those relationships have meaning. Right? When we meet somebody, I shake your hand, or in the old Greek way, we shake our forearms. Right? In France, you kiss both cheeks. Here, we kiss one, right? Let's make it your way. Okay? So, if it's traceable, that has a relationship. So to your point, I'm going to prove it even further with relationships. In the language, there's a notion called satisfy. I'm telling you the parameter of the battery is satisfying the requirement of battery length, time, and longevity. Okay? When I run my solution through a simulator, it's built into the tool, I get a pass-fail because I'm using a relationship of traceability called satisfy, and that relationship says that it meets that, or I'm telling it does, and the computer says not a chance, fail, go do it again. And we'll go in a little bit deeper. But does that make sense? So within this, we started with boxes and lines, now I've added lots of them, and I've even added textual requirements. Is it making sense? Is the story making sense to you so far? Have I lost the room? I don't think so. Right? What about you guys? You good? No? Okay, good. You haven't asked a question yet, so I'm worried. So, in sequential order, like I promised, I'm going to tell you how you get there. One of the greatest things about INCOSE is that they tell you the life cycles and the way you manage your project through their eyes as systems engineering experts. Dassault Systems calls me an expert. But what's the definition of expert to you? Everybody has a different definition of a word expert. I don't consider myself an expert. I consider myself someone that knows how to use the method, the tool, and the language. You'll learn about the language on your own. If you want a book about the methods that we use, I'll send you a book. Right? I already asked my admin to send 2 boxes because I couldn't get to them before I left. I will send you 2 boxes, so 22 books. If I have a 3rd box, I'll send you a 3rd box. And you guys at the university can use it, or in the academy, we can go from there. Why is the method so important? It's repeatable, yes. What's another one? I'm looking for one word here. It's proved. Yeah, one more. Why is the method so important? Organization, very, very close to what I want. I'm wording one word, but I'll give someone else a try. Anyone else? It's very close. You're 99% there. Define or structure. Right? Understanding. What was missing in the video? Structure. Yes, they started with collaboration afterwards because like, oh my gosh, we got to build it back up. They started sharing, but structure is a method, eh? Right? So one of the greatest things about this solution is it's method agnostic. I don't care which one you pick. Pick one that's best for your organization and stick with it. Apply the structure. If it doesn't work, try another one. Guess what? You don't have to change a lot of your data. You just have to change how you organize your data. Does that make sense? Have I made things easy? I think we're getting there, right? All right, so I am going to show this video. It is a tool video. I will talk to it and I will pause it and explain. But so far, everything that I've promised you this morning is going to show up in the next 3 minutes and 22 seconds. Okay? And then we're going to go into it a little bit deeper. At any point, you ask a question. Okay? It's 3 minutes, and I'm going to stop it at least twice. No. You know, PowerPoint has a mind of its own sometimes. All right, so this was a commercial that we built for INCOSE, but it really talks about getting to the next level with a modeling tool. We'll talk about that slide in a little bit. Here's a method. Our method's called Magic Grid. It allows you to take the systems engineering concepts, right? Requirements, functions, behavior, structure, and safety, and bring it all together. Did everyone catch that? No? Okay, let's go back. That's okay. I'm here for you, remember? Okay. There's a lot of pretty pictures up here. Does anyone believe in the term a picture's worth 1,000 words? Yes? Awesome. What's wrong with this one? Like I said, guys, if we're not having fun today, I did not do my job. Okay? Everyone so far is pretty close to smiling. We'll get you at the end, I promise. When we look at this, I've broken this down into the 3 major functions of systems engineering. Conceptual design. Right? Everyone at least understands conceptual design. What about logical? Yes. Very good. Yes, the very top. So the conceptual is going to make up our white box and black box designs. Everyone know what white box and black box is? Yes? Good. I don't need to explain that one. So if I'm taking a conceptual design, I'm really building out my mission, high-level stakeholder requirements, my MOEs. What's an MOE? No? I figured I'd get somebody. MOE. All right, in systems engineering, it's a measurement of effectiveness. Why is that so important to us? Oh, I'll get you. Don't worry.
You do the preference.
Yes, right? But those are coming from my stakeholders, right? Yes. So if I get stakeholder requirements and I get MOEs from my stakeholders, I get it all to come together, right? Okay. I will try not to stump you in the future, but I encourage you to try to stump me. Okay? We'll play that game. That'll be rule number 3. Stump Jason. All right. And we'll talk about maybe that later today on what that really means. So when we look at this, the middle section is going to be the logical design. It's really when I'm getting deeper into the system. I want to maybe bring in electrical, bring in software design from an architectural perspective. I may not say these are the must-haves, but I have a notion that I think these will help my system satisfy the requirements and be simulatable. We all good? I may know some of the hardware components or physical characteristics of my system, and I'll put that at the bottom, and then we'll use a relationship of traceability called allocation and go all the way back up and show the stakeholder that, hey, I can go all the way down and I can show you how it's perfectly back to the original requirement you asked of me. Sounds easy, right? I told you I can do it in 15 months. Very hard to do, right? But is it? We teach, we learn, we teach ourselves, we learn some more, we'll get there, right? We'll get there together. So let me push on the video. We'll talk about in the next 12 seconds about requirement and how and what the importance of the requirement is within this missile design and where we're going with it from the missile itself. Okay, what do you see on the screen? Boxes. So I haven't confused you yet. So if I haven't confused you, please pause. Okay. So what am I doing here in the video? I'm using requirements in the pink box in the upper right-hand corner, or left-hand corner for you. Okay, so we call those the pretty pink boxes. Those are requirements. All right, I am going to get a little technical, but I promise you they'll be at high enough level. If you get confused, raise your hand. And do not be afraid. The requirement here, and I'll read it, and I don't like reading out slides, but I want to. So the missile range on a bad weather day shall be more than 80 kilometers, right? Or kilometers. In the pink box. Okay. And I talked about the relationship of traceability called the satisfy, right? Right there. See this? So flight distance is satisfying my range of missile, right? That's plain English, right? We all understood that. I didn't confuse you, and it's not complex. Well, what is part of my system, from what we call a structural analysis, is the missile has a propulsion system, it has a control system, flight control system, right? It has a navigation system, and I've decomposed it one more time. It has, what, a GPS reader, right? A reviewer, and then I have an airframe of structure. Is it confusing? No. Okay. So what I'm doing here is I'm prepping you as the stakeholders in the room that I'm saying I'm going to meet your requirement that this missile can fly. Oh, jeez. I wanted to get to the fun stuff. Is everybody okay with the pace? All right. Does everyone know how to use MATLAB? No. You use. Okay, so what I'm doing is I'm integrating interoperability of tools. Bring MATLAB in, I do my parametric design, very complex, I'm sorry, but it gets me to my point. The point is, the tool works for you, you don't work for the tool. Well, let me repeat myself on that one. You work for the tool does not work for you. What do I mean? Data in, data simulation. There's your answer. Did I have to do anything more but use my brain to put what I know into the tool? The tool is awesome. Okay, I've been using it forever. I'm biased, I'm so sorry. Why am I biased? Because it does not allow me to do it incorrectly. And you're going to say, Jason, that's not possible. That's what AI is for, right? Yeah, I'm getting some more to a smile. I gotcha. So when I drop something onto what we call the canvas, this is our construction. Red. So if we go back to that other screen with the pink box, if I try to put an element type on the box, it will light up red. If it's not what we call contained or typed, it will light up yellow. If not, it won't say anything. Or if I want to drag it to something else, it'll be blue and we're all good. So if it's red, it's incompliant, right? Either it won't let me drop it or it'll stay red and it'll be really ugly. Lights up like a Christmas tree. Okay? Red is bad. Yellow's okay. It's a warning. And nothing is awesome. That's why it's great. It won't let you model incorrectly. You can model as ugly as you want, but you can't model incorrectly. No one got that joke? Okay. So, in the video, you saw that the bottom right was red for a few seconds. I made some changes to parameters, and guess what? Now I'm green, and what happens? Everything works, right? Well, if everything works, I want this thing to fly. So I'll jump ahead, and then we'll move on. I'm flying the missile. See? The behavior is flying, red, green, yellow, red, right? Stop in this case. In the upper right-hand corner, this is my favorite part of the tool because I'm lazy. Who's a lazy engineer? Every one of you put your hands up. Okay? If the tool can do something for you, why would you not take advantage of it? Has everyone heard of a sequence diagram? How a system or a function talks to another or multiple things in a certain amount of time, right? The tool will automatically generate you a sequence diagram. So I'm a lazy programmer. What's the number one thing I need to have in architecture is a sequence diagram. I have to show all the different components of the system of how they talk to each other. So why not let the tool generate it for me? Where it helps you in your everyday job, that either whether you're in aerospace or not, is that it'll do trade study analysis for you without pressing a button. Why? Because if you put the math in it and you put the data into it, it's always running. One of the things that I love about that is that it helps me build a MBSE culture. So, let me ask you a systems engineering question. The hardest one of today, what is culture to you? Think about the video. How we do things. Yes, I agree. And if we do it right, we are successful, right? And if we do it wrong, we have the ability to fix and do it again. Yes? That's why we're engineers. That's why we like math. That's why we like to build things. That's why we like to destroy or create. So we talked about requirements a little bit ago, and I can say you have to have requirements understanding or a requirements tool to get to the end goal. Without a requirement, you fail. Why? You have nothing to measure. It's not just go build me a new CubeSat. It's not just go build me a new vehicle. I don't know what needs to go in there. There needs to be requirements. There needs to be process and structure, right? We all still with me. So what's next? If I have requirements, what do I need to do next from what we've learned this morning? Design? Yes. The model, right? So architecture. So I'm getting from point A to point B. I'm getting closer to the culture. If we do this, we should be successful, right? What do we think is next? A lot of different answers. This is how I do it. No? What about verification, validation? I want to validate my architecture. I want to simulate. Yeah, probably a really good answer, right? Look at this. I haven't found my aircraft yet, but I'm going to fly somewhere, right? And trust me, I have one of these for every domain and industry. I picked this one because I was coming for these guys, right? And I like the F-35, even though the F-22 is better. You guys fly the F-16, my favorite aircraft of all time. Why? Because I wanted to fly. except for baseball took over my life. Okay? Another day, another time, a drink on me, and we can talk about that. So, without that distraction, since I'm simulating my life for you, what would be next? This one's harder. Prototyping, very good. Actually, you're right on. So within the prototype, I might have 5 or 6 different variants, right? Guess what I just put on the screen? Variants. Did you have this ahead of time? You're the first one in 5 years that's ever gotten that right. Congratulations. I'm being serious. I do this talk all the time, right? It's one of my favorite talks of this slide particularly because variant management is very interesting. And at the very end, I'll show you an even why variant management is so important to MBSE. All right, it comes back to the simulation and trade study analysis of what is important. So in the next, we'd probably, say design? Is that fair? Now in the next 2, we can do either or. But in my order, I'm going to do design with CAD. I want to integrate. I want to talk to them. I want to bring them into my house and say, hey, I need the system to do this. Design me parts and functions to do what I need. Is that okay? Let's do that. So we use CATIA or SolidWorks to do that, yeah? So what am I missing? I'm missing one crucial component in today's life. We've hit on everything but one major engineering domain that we probably have to have. ConOps, we would have done that with requirements. Nope. It's an engineering domain, and ConOps is part of enterprise architecture. End of life? No, because I'm going to blow it up at the end. Right? I want to kill the other aircraft, right? And you'll see a cool video. No? Software? It's not important? Oh, what? Coding? Yes, software. Exactly. So if we put all of this together, what do? We can find the aircraft and... but it's not red, is it? It's green because we created the culture that I asked for, right? Does this help bring it together? Right? It's better than the pictorials, right? Or did you like the caveman? When we look at the culture, it builds us into the next level of engineering. How do we do something better than what we were doing? Why is MBSE the number one thing we talked about inside of system within engineering itself? In the US, it's the biggest buzzword in the world. MBSE, systems engineering, I'm doing so much more, I'm so great, I'm awesome. If I wanted a job out of college today, and I was a systems engineer, I'd get a job at a very high rate. Software and systems right now in the US are the top 2 jobs out of college. Systems engineering normally takes about a master's degree. We'll talk about it in a little bit. But it gets us to this. What are the 2 things that you've not really looked into in your career that are on this? Name one of the 2 things that you're not familiar with, just for fun. Accelerated development, what does that mean? I would say by modeling and simulating effective black box and logical design, I'm accelerating to getting to my end goal so that I can work with what I call downstream engineering, which is CAD, fluidics, electrical, and I bring them forefront into my life cycle of my system V. Have you noticed that none of my slides have a V? It's on purpose. Okay? So there's 2 words on here that I want to talk about just a little bit, and we'll talk about it more in the next session, but it's the standards and frameworks. Standards and frameworks drive our solutions. Without standards, we can just do whatever we want. Without a framework or a method, either word works, we're unstructured, and we can't be together. Because everyone's going to do their own thing, and then I don't know how to connect a box and a box. Does all this make sense? Yeah? Okay, good. Because when we talk about these case studies, I want it to be real for you. All right. Let's talk about telescopes. You guys are from Chile. You guys are familiar with telescopes, right? Okay, so when we talk about the 30-meter telescope, no, it is not going to be built in Chile. You denied that one, and it's totally okay. But it has significant value to systems engineering because when we look with systems engineering, the number one success to start your thinking of your process with systems is controls. Why control systems? Because I can model out my functions. I can integrate all my hardware. I can understand what's going and not, right? If things change, I'm doing analysis right away, correct? I speak the truth, right? So within TMT, when they wanted to make a movement or a change, the requirement may have changed. And you can see that, right? I'm showing you the lines that have changed. And if we walk through the system of 1 through 6, what is so great about this? I'll do my best with the pointer. So in 1, we saw that our requirements changed. In 2, in the model, I had to do all of my requirements from doors. That is a doors database, I promise. And I brought in my requirements to update inside of the model. From the model, I moved over to look at my analysis and design. And then in the middle, I looked at my trades. I did my variance, right? My ICD tables, maybe if I was doing electrical. And then I brought it all together and I got a pass-fail grade. So I just gave you a life cycle, did I not? Does anyone think that a telescope is complex? Extremely, yeah? So I'm winning. Well, but you win too. I bring it to you. So one of the proudest moments in my career, besides everything I've already lied about, was that in the US, there's 3 major land-based telescope companies, and we're part of all 3. Huh? So does anyone, let's see if you guys know your own culture. How many of these telescopes on the screen are based in Chile? Huh? 3? Yes. How many are using the MBSE solution from Dassault? Out of the 3? 2. Do you think that's a win? Wait a second, look at this. There's 5. Okay. They're all using MBSE, some with our tools, some with not. Out of the 5, there's 3 in Chile, right? And 2 are using our solutions. Is that a win? Is that a win for Dassault or is that a win for the community of telescopes? Haha, the Dassault team says both. I would say both, but I would say this. Think about what I said. The 3 companies in the US, they transformed to use our solution. They've proven in papers, go find them, that they've been successful with MBSE. With our solutions. Now, the other telescopes, go back one more again, they are all using MBSE, maybe not with OSO systems, that's okay. They're all using SolidWorks, I promise. Okay, but within that, how are they being successful? They're being successful because they're using the methods and tools. Who are they working with? Who, in my opinion, it's mine, personal. I would say JPL is probably the leader in MBSE when it comes to space. Anyone want to argue with that? You didn't want to say you guys are number 2? No? You can get there. We can help you. So why is JPL up here? JPL's up here because I'm in love with space stuff. That's probably why they picked me to come too, is I can talk about space until I'm blue in the face. Okay? So many projects, many projects. Mars 2020, the rover, Perseverance, 30-meter telescope. Yes, JPL is very in tune with the telescope community. A lot of their scientists look at adding different types of technology within there, and there's a laundry list of programs. Okay? So which one of these is so endeared to my heart? I would say the Europa Clipper. Does anyone know about the Europa Clipper? The Europa Clipper. It's a satellite that is going to go to, or a probe, excuse me, that will go to the Jupiter moon Europa. It's a water-based moon. Why is it so important to me? Well, 1, I was on the project for 3 to 4 months. Well, 2, from the first requirement written until launched back in October, it's used MBSE. Is that a feat? Is that a success? It's a success for the room, right? But is the success over? It's only launched, right? It hasn't deployed. We have to go to Mars, and from Mars we'll come back to Earth, and from Earth we'll use the trajectory all the way back to Jupiter. Right? It's all about timing and physics. We learned how to do this. But when we look at this, to me, it will be the #1 papers over the next few years because since it's launched, they're allowed to write more about it. Why is that important to you? It's proof it's working. It's proof the methods that they did go into the way. You guys want to hear about a joke about the Europa Clipper? So when I was there, it used to be called, in the holiday spirit, of course, it used to be called the Christmas tree of programs. What did I say? The Christmas tree of programs. Why? So, NASA's all about science and doing something bigger and better, and no one can defeat us, right? So, they had 60 different instruments that they were going to put on this probe, and they chose 8. They chose 8 out of 60. So why was it the Christmas tree? Because they had to do trade studies against all of it. And then there's the political battle, and the money battle, and then the engineering battle. You go farther up the road, what technologies we're going to use. The guaranteed technologies, 3DS and CATIA Magic, right? That was guaranteed because that's the MBSE tool from start to finish. You want to talk with them about programs, I would put you in the head of systems engineering, or at least the program officer at the time. His name is Christopher Delp. A very good friend of mine, allows me to come talk about these things on their behalf. But what else makes this fun? I can bring it personal. I'll tell you, not just me working on the program. It was 3 months. Who cares, right? Is that I got to go visit and I got to see it be built, put together. I was there. I promise. Okay. It's Photoshop. Oh yeah. No, I could put more on there, but it's a proud moment, right? Is that we're part of it. You know, we're an acquisition to Dassault, the team and I. But to see it from start to finish and now it's launched, all we have to do is hope it works. If it works, it's a success. We're already a success because it's launched and it didn't blow up, right? But when it opens and it gets power, so as soon as it gets to Mars, we'll open and we'll start communicating with it, right? There's small communications now, but it's normal stuff. All right, the #1 case study in the world. And yes, you can have the papers. I have both. There's a lot of information here. And you all are not part of the Navy, but you have to communicate with the Navy at times, eh? So, why is it the #1 case study in the world? It's the only case study in the world that gives us ROI data. Unless you are a COSI member, you can go search some more. Why do I get to talk about this? Because it's a very, very public paper by Lockheed Martin. Why does it help you? Why is Lockheed dumb enough to tell their competitors that they're doing this better than they are? I use a very key word. They're telling their competitors that they're always going to beat them because they're using model-based systems engineering. Is that key to you? It's not. Why do we care about ROI? So the stakeholders in the room, that's one of their #1 requirements. How do I save money? How do I do it better? How do I do it faster? How do we get to launch? How do we do it safely? How do we reduce risk? How do we reduce team members? Blah, blah, blah. I didn't miss anything, did I? So when we think about that and we talk about savings, so this is 17 years ago. They had 2 teams, traditional requirements team, doors, Excel. Then this cool tool called, well, now it's CATIA Magic, said we're gonna go against you. We're gonna do requirements and we're gonna build something. What's the difference? Model-based, textual-based, paper-based. We've been talking about it all day. Yes? So we reduced all the complexity by bringing architecture earlier into the design phase, or the development phase, right? Simulation wasn't out yet, but in paper 2, you can talk about simulation. But in this, so I'm not lying to you, the modeling took longer. It's in the paper. They tell you about it. Modeling took longer, but it saved them more. It took longer, but they saved more money. Is that the calculated risk you want to hear? Yes and no, right? So, and I'm talking, so the largest program ever in the US was $1 billion for Northrop Grumman 4 years ago. So this, I think it was like 800 million for the SWIFT program for a nuclear submarine, the newer one. This is what they did it on. But here's the data, the raw data. They give it to you. Again, why is Lockheed telling us, the competitors, meaning all of us, that they're successful? Because they want to continue to show that it works. It's not just a better Lockheed and to rub everyone else's nose in it, but it's to better the community. The community of systems engineering. I told you I came here as a neutral party, right? That's what I'm doing. Yes, our tools are used, and I'm grateful for it. And it's allowed me to do many cool things. But when it comes to the savings over a period of time, this is the proof. This paper is 10 pages, the other one's 4 pages. Read it on. I will send it to the team. They will give it to you guys. The importance here is showing this is an 8-year, 10-year program of all the different savings that they did. And what I think is most significant is not the big dollar amounts over a 5-year period. Apologize for turning my back. It's this one here. The MBSE with SE only savings is way down here. But when you add everything else, my maximum savings or my estimated savings, yes, they're significant. But when we add everybody to the game, we save more money. Go back to our video. What are we trying to do? We're trying to bring the cultures together and collaborate more effectively, eh? Okay. I will make sure the team has the papers and you guys can have them. Okay? And I'll get them to you today. I have them. So for the educators here, the people that want to continue their career, this is my opinion on how you can get there. Okay? No, it's not as fancy as everything else, but you can get there, I promise. So, systems engineering, software engineering, mechanical, etc., software, blah, blah, blah. Okay? How do we do it? Where do we do? Why do we specialize in something? It's because we have a passion for it, right? How many times did you change your major? You never changed your major? Oh, that's a first. You changed your major? At least once? 2 times? Okay. I still haven't finished. And I'm not an engineer by trade. I said that, right? So what do you do? So if I'm not an engineer, what did I specialize in? Let's take a guess. I was a baseball player. And I don't have any college debt. I got to play for free. For 6 years, I get to play for free. Injuries plagued my career. Does anybody want to guess on what I majored in? Non-engineering. Dual degrees. No? No guesses? No one wants to play the game? Teacher? I tried. I can probably be a good one. Yeah? No, kinesiology and nutrition. Yes, I know that. Okay? My wife actually makes fun of me. You did all that work for nothing? Okay, yeah. But she'll tell you that she made this, not me. Okay? So if we think about building up our knowledge, right? Knowledge building. Where do we go from there? You have to have experience. Can you be a systems engineer out of college? Potential systems engineer though, yes? Potential. You should know the concepts that you want to get into, yeah? Okay, good. So do you think I missed anything here? Or is this pretty true of what you think you should be doing? Okay, so if we can't do real world, what do? We have to develop our skills. And when we develop our skills, what happens? We become better engineers. We become better leaders. You become better communicators. And you drive for, what is your drive when you do all of this in succession? Success? Do you want to be successful? Sure. It's a personal goal, yeah? Okay. So what happens when I bring it all together? Do you think you need everything? Done? Okay. So I'm going to break it down 3 ways. This is my opinion. You tell me where I'm wrong. Okay. I want to maintain my engineering growth. I can do it here. Huh? Makes sense, right? Well, what about if I'm career ready? Do we know what a career is? And I'm not being derogatory with that. When we leave college, where we're at in our career right now and right here, do we know what we want? Trust me, I've been doing this forever and I still don't know what I want. I don't. My job is to try to make you successful. How do I make you successful? I ask you questions, you give me information, I show you how it works in the tool, and I walk away. Goodbye. And hopefully you bring me back. But if you do all of these things, I promise you one thing, you'll be MBSE ready. How do you get there? Where did you start? Why? Tell me. Because if you tell me, I'll tell you how to be successful. Yes?
You talk about the
Yeah? Yeah? Yes? Yes?
we are working the young to come from here.
Okay.
But it's we are small.
Yeah, absolutely.
It's really hard for the financial.
Yep.
It's not too much to do each time.
Yep.
Here in Germany, there's working something,
Yes?
but we are not at all there.
Yeah, absolutely. It's too hard. Yeah. Yeah. So I went back to this one to answer your question because I don't want to go all the way back in my deck. So, entry-level roles, that to me, to answer your question, I'm not talking about only get people to do engineering at the basic level. When, no matter the size of the program or project that I've seen, it starts with 1 person. It starts with 3 people. It starts with 5 people. Yes, it's an incremental, right? But it takes 1 person to believe. It takes 1 person to convince that we should be doing this because it's the right thing to do. There's a process slide. Now, your question I will answer pictorially later. If you have the believer, in the US, there's a term from a movie called Field of Dreams. If you build it, they will come. So, what does that mean? If I adopt it, we will be successful. I'm going to change the language. If I adopt the method of MBSE and systems engineering, I should be successful. Because I can't guarantee anything in life. It's your interpretation of the language. That makes sense? So, to get to the answer to your question, it does take a process. You start with the believing that it will work. I then convince and understand what I could potentially do with this solution. I start a pilot of the solution. I show success with it. And then I adopt it company-wide. You have to, and it's an old term that we use to phrase, you have to start small and evolve. But you have to commit. You cannot be willy-nilly with this. It's too difficult. Why is it difficult? Because you have to learn. And it's not just one person learning, it's everyone on the team must know what to at least read the model. Wait a second though. If everybody needs to learn how to read the model, what does that mean? I need to learn how to read the box and line, right? You can read your own language, yes? And you can read the English that I put on the board. Is that enough? If you're the engineer, you focus on the engineering. Again, I repeat myself from earlier, the tool works for you. You put the data in, it does its job, you, pictorial, make it work. A picture's worth 1,000 words. However, the picture's just a picture. Everything that we call a containment tree is the system of record. That's what matters. The pictures are what you want the bosses to see. We've met these things. We're doing this. This is the output of what is to come. You have to start with entry level. Start with the basics. Start with understanding where you go, because then this because comes the key to success. And then I'll give you the process slide to show you exactly what I just explained. I just took it out of the deck because we all agreed it wasn't necessary. Now it was. This was fun. So if we go through this is what I think would be MBSE ready, but guess what? It actually is all of it. Just because I don't have a degree doesn't mean I'm not an engineer. I'm a wannabe engineer. But can I do MBSE? Yes. Can I walk you through the tool? Yes. Can I execute the tool to ensure that it's going to be successful? Yes. Can I integrate it with other tools to the limitations of the tool? Can I build something to integrate something it's not integrated to? Yes, the APIs are very rich. Can I help you and put you in front of the people that have helped me get to where I'm at? Yes. You want to know? I'll give you what I know. What does that do? That means we have to understand what's going on. Transitions are working, right? If we look at, you have to invest early and often. Who's heard that term? But if you don't commit to the investment, you will fail. You choose to do it, go all in. Why? The rest of the world is doing it. Why not you? What? That's an excuse, is it not? So then, what makes you make the right decision? Is it about the gains? Is it about the money? Or is it about the transformational process that you need to implement to be successful? How does architecture help you with that? We have to have a common ground. The model is the starting point. The 3D experience helps bring all of that together. That's my opinion. The first person in 5 years to understand that variants are important, guess what? Look at the screen now. Look how important it is. And if we see that, we have to understand how we get from as is to 2BA, 2BB, and 2BC to ensure stakeholder needs throughout its life cycle, throughout what we're trying to accomplish, and to make it better. If we understand that, guess what? I make more money. The systems engineering is the what? The puppet master. And if I do all of this correctly, I mastered correctly. So if we summarize all of this, is it really about saving money? Yeah. Is it about reducing errors? Have I proven that? To an extent. Right? Collaboration is key. And if you build it all, you'll make it work. Did I hit on all these points today? Yes? Does everybody understand what it is? You guys can have these slides when I'm done, and you can have the videos as well. When we look at this, all I ask of you today is you come join and learn. Why? I told you I want to learn something new every day, right? I live in this community too. I want you to live in it as well. If you join the community, you can ask questions to the biggest experts in the world. Not just the Dassault team, you can actually get to everyone else. Why is that important to you? You can overcome your fears and doubts of what I just explained to you for an hour and 20 minutes. Is that important? If we move forward together, we can be successful together. Just because I'm based in Dallas, Texas, does not mean I can't help you. Why? We're part of Dassault Systems, and we want to make a partnership with everyone in the room to ensure success. Our number one goal is partnership success. You join the community, I will prove to you success. There's papers, there's data, there's YouTube videos, there's everything you ever wanted to know about MBSE right here, right now. Everything I just lied to you about for that hour and 20 minutes, all there, I promise. Does anybody have a question that I have not answered today? In the basics of systems engineering. And your question was very good. Do you have another one? No, okay. You can. So, at Dassault, we have 3 ways you can learn. You can learn online at your own pace. I'll find out later today if you if there's a Spanish option or not. I think there is, but I'm not going to lie, so I don't know. So online, in person. So the systems engineering course is 5 days. The simulation is 3 days, which is done 6 months after the systems engineering course, because we want you to play and learn. Or we can send you books about Magic Grid, and Magic Grid is, the book itself is a tutorial. So what we did was we built a book that allows you to learn the language, learn the tool, learn the method. Oh no, I just gave you 3s. Who likes football? Soccer. Soccer. Okay, so in Chile it's soccer. In Brazil it's football. In Europe it's football. In the US it's soccer. Jeez, I can keep going. Football. Oh, okay. Well, not in the US. Yeah, we're dumb. Yeah. Okay. No, I don't like that football. That's stupid football. I actually like soccer. My son's a soccer player, so it's keeping me on my, and I'm learning a new sport. So, when we look at all of the different things, because I lost my train of thought, you have those options to take on the learning. And I'm giving you another option of this community to learn more. There are also Dr. Saulius Babalkis, who helps me out in every aspect of my engineering, who is our head of integrations for the CATIA Magic, and our lead MBSE person would say, join his YouTube. Why? Because he posts a new video of 5 to 12 minutes every 2 weeks. All about simulation analysis, requirements analysis, structural analysis. Our newest thing we're now doing is we're going from 0D, which is the model, to 3D manufacturing CAD. There's a new video we posted about a robot, a robotic arm that he can actually drive from the model. What did I do? I brought design closer, right? Earlier in the design phases. So within that, if we work together at growing the community is successful. All I'm trying to do is give you the information for your success. Good? Okay. Oh, there's the process. Told you I had it. So this is the process that we would see a typical company take on, and it's in the deck, and I'll give it to you. Any questions? All right, so we have 22 minutes. Man, I'm doing pretty good on time here. Let's, has anyone heard the term, your head's going to spin? I'm going to confuse you, and that's okay. Why am I going to confuse you, and why do you think it's okay? Because I'm mean? All right. So let's answer the question, can you architect the world we live in? The world is continuing to change, but can you architect the world we live in? Sure. Okay. Yes, we could. Yeah, I agree. We can. So, does anyone even know what UAF stands for? We have 30 minutes, right? Okay, good. UAF. No, it's okay. I want y'all to interrupt me. You guys have been very bad at that. That was the #1 rule, remember. Unified Architecture Framework. So unified architecture framework, why is it important to you? So I'm going to divide the room. Who's a contractor? You're a contractor, put your hand up. You have 1 contractor, 2 contractor. Who's part of the DoD? Arms up. DoD, Air Force. Okay. So who's academic? University. Aha. Okay, I knew you guys were hiding somewhere. Who's heard the term enterprise architecture? Term, enterprise architecture? We have a winner? Okay, good. All right, so I'm going to confuse you, and that's okay, but let me give you the basis before the confusion. We just learned about SysML, right? Does anybody know the foundation of SysML? Comes from UML. What does UML stand for? Unified Modeling Language, and SysML I told you, do not answer this one. I told you what SysML stood for earlier today. What does it stand for? Systems Modeling. Okay. Well, UAF is a higher term building off of that. So UAF incorporates UML, SysML, and more. And I'll explain it one more time in a few seconds. So if we think about complexity, I'm going to make it more complex, but I'm going to reduce the complexity by allowing you to do more. But then you're going to tell me, Jason, you just told me for an hour and 20 minutes that everything I want to do, I can make it easier. Now you're going to make it harder. I'm not going to make it harder. I'm going to make it more fundamental. How can I do that? Is it even possible? It's possible, I promise. I'm not going to totally kill you. Okay? But we have to look at it as a key fundamental capability from an enterprise perspective. Enterprise. Who's the enterprise in the room? The university is an enterprise, yes or no? Yes. Is the Air Force an enterprise? Yes or no? Is the contractor an enterprise? Yes or no? Yes. Who is the master enterprise in the room? Yeah, I'm using the term master. Who is the ultimate enterprise in the room that brings university and OEM together? All right, so one of the 6 answer this one. Who is the ultimate enterprise in the room? The Chilean government? In this case, yes, you win. So, why? Because if you use UAF, you're showing everything. You own what? The capabilities of the system. Do you not? You own the requirements of the system. You own the operations of the system. What do you want the OEM to do? The contractor. You want them to build it, right? You want them to ensure what you gave them was correct? You want them to ensure their people are certified. Do you dictate that? Yes, you do. I promise. I'm going to prove it to you. Okay? Why? Because we're going to bring all those languages together, and we're going to show how utilizing this between 1 system, 2 system, 3 system, and 4. And I have an awesome example that's non-military that everyone in this room will be able to understand. I'm going to break it down. Are you guys ready for the roller coaster? Come on, it's been a whirlwind all day. But before we get there, we have to understand where we're coming from. UAF is derived from the US DoD after 17 years, 18 years of doing a language called DODAF. Then it became UPDM, and now it's UAF. And it comes with a notion to bring all nations, I'm going to use nations, architectural frameworks together to live in one house. And then they can use the language the way they want to do it. What do I mean by that? Everybody heard of NATO? They have their own framework. Everyone heard of the US DoD? They have their own framework. What about Chile? Do you have your own framework? Yes? Well, we can see if we can put it in here. If you're not part of the OMG, we can make that happen, right? So bringing all these frameworks together allows everyone to live under one roof. But wait, you just said, Jason, you did DODAF, you did UPDM, and now you're doing UAF. What's the difference? The difference is in UAF, we want to incorporate the business. It's not just for DoD. It's for understanding how architecture from the enterprise can be controlled and understood by the masses. I can see how one program can reuse data to another program, and so on. Or I just need to know what all my programs are doing so I can align my resources and ensure security against my whole system. Think of the very last bullet you see on the screen. If you can't tell, I very rarely read from my slides. But it's very important. The lack of integration, capability, and interoperability between systems. I'm changing that with this. Enterprise architecture brings all of it together. And we have to talk about the benefits, right? I'm going to go through this one quickly. But look at this. How many overlapping capabilities do we see within this from the UAF benefit? So then, are they all overlapping? For the most part, yes? No. Yes? Okay. So if yes, why am I changing languages on you? To confuse you? To tell you you have to buy something bigger and better and that's what I'm here to do? Absolutely not. I'm here to show you by utilizing a one level of higher way of thinking allows for better productivity into the system design. Think higher. Think more abstract. What do we talk about? Systems thinking, right? You think outside the box? How big is the box? How big is your box? Think about yourself. Think about your goals, your personal goals, your career goals, your family goals. How big is your box? How do you think out of it? How do you make every single one of those perfect? Are engineers perfect? No. Are we as humans perfect? Are we as humans unique? Yes. What did I prove? We all know how to think. We proved that when you ask why and how, you get an answer. How will this benefit me? It's right there. How is this different than SysML? I'm going up a level at a higher level of abstraction because you should not own everything. They own the functions, you own the operations, they give you schematic, and you say it meets my requirements. Voila, partnership. Why do you own operation? Huh? Say it again. I didn't hear you. Yes? Yes? Absolutely. So if you own operations of how all of it should work, right? And they prove it to you inside of the schematic that it will work, you're ensuring what? The operations are complete, the requirements and capabilities have been met, and the resources that you allocated are there, right? Well, let's prove it. Let's prove it. I'll skip this. Let's prove it here. Everybody know how to farm? Does everyone own a farm? No one owns a farm and no one knows how to, right? Who likes to garden? Who is married? Let's ask this differently. Who's been told to go pick up the weeds? Huh? Okay. Has everybody heard of this Jolly Green Giant? Yes? It's undeniably a famous company, right? Why would they need enterprise architecture? They build the same tractor since 1912. The same tractor, all they did was paint it green and yellow. Right? There's been an evolution. I didn't put any personal pictures in here, but I go here 4 times a year to their headquarters. It's awesome. Okay? So let's talk about how they applied it. They approached it differently. They approached it with understanding that it's going to take methods, it's going to take a tool, and it's going to take an understanding. I can tell you this, the head systems engineering team did not like the team that wanted to take this on because they thought it would fail. What did I just say? The systems engineering team told the other team across the pond in Germany, said, you will not do this because you will fail. So I got on my pretty little airplane and I flew And I proved to them in a short presentation that they could be successful and we will pay for their pilot. Wait a second. The tool vendor paid for their pilot? Why would I do that? To prove it? I'm pretty passionate if you can't tell, right? I wanted to win. I like to win. But I had to prove the technology. All right? I'm hoping that I'm proving it today, but if we think about this, they were extremely successful. They were so successful that 2 of them got promotions out of it. They were so successful, they came to our conference in Dallas last year and they presented this paper. Why? Because they brought everything together within the organization of the farming side of the world. By doing what? Now, there's some slides I took out of here just because I didn't want to bore you, but let's look at the timeline. If we look at the timeline, that's what they were trying to accomplish, right? They wanted to understand what was going on. Wait, words, as is. As is. Have I been a broken record about that today? The green deal, the 2B, and then the 2B. So they have 2 2Bs. Why is the green deal a 2B in my eyes? Yes. The ambition of to get to the end goal, to the next version, to the next capability, which gets us into here. Our goals. They have phases, they have goals. Right? You have goals. Satellite must fly. Must be in orbit for X number of years. Must communicate. Must launch. Have I missed anything? Right? Basics. Those are my goals. My capability. Must send data every so long. Must be able to change flight plan. Must reuse. How are you going to make that happen? Maybe, maybe not. You drop it in the ocean and maybe I save some of it, I reuse it or not. Is that important? It's a capability. Have I lied yet? No? Okay, good. So, and then, wait a second. I have to do an operational scenario. Did I lie? You own operations, right? They now own operations. They understand their business very well. When we understand what's going on and we look at it from a top-down perspective, we find the solution. How do we get there? We get there by looking at how systems engineering drives from a top-down approach. Not just building and making it happen. Will that work? Will building and making it happen work? Yes, 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 yes. I promise it will. I proved it for an hour and 20 minutes. Okay? Why is this level different? It's different because I'm involving multiple major systems of the tractor. They're not just subsystems. They're reusable in any other tractor. It's either a 4-cylinder engine or an 8-cylinder engine. They only make 2 or 3. Every new tractor must be compliant within those 2 or 3. So that means propulsion or engine design is a system. Is it a subsystem of the major system? Yes. But in this case, it's a systems of systems architecture because I'm asking that engine to communicate with the smartphone. It's outside of the system. I need to know my GPS coordinates of my new land. Separate system. I needed to talk with my plug-in computer. Separate system. And I want to operate in the cloud. Do you trust the cloud? Do you have your own cloud? You have to understand those things, right? When we talk about this, those are outside systems. The engine is inside. It's a subsystem of the major one, but I can reuse it. I can make it communicate. So then I'm creating a bigger architecture. I'm trying to paint you the picture of why this is important to you. Why? Because, all right, we're going to play a game. You have the GPS system. You have launch. You have the actual aircraft. And you guys don't have anything. Right? So, if you 3 are the system, what system are you inside? Think higher. Think wider. Think anomalies. It's not physical. What division are you in? I'm not trying to stump you. Engineering. Space. Land. Okay, space, right? So what do we call space? It's not a trick question. What do we call space? Space. Okay. It's not a trick question. So is space its own system? Capabilities, operation, systems and system architecture. If I say space is the major system, I want to put something in space. I'm putting it into the system, eh? Is a planet in the system of space? Yes? Good. Are stars in the system of space? Okay. So let's decompose Earth. Make it easy, right? So we have space. We decompose Earth. Earth has water. Earth has land. Earth has atmosphere. Earth has biological beings. Animals, right? So we just decomposed it. Is atmosphere a system? Or is it a subsystem? Subsystem. Is land system or subsystem? Subsystem, okay. But is the planet a system or a subsystem? System. Okay, see, I'm making you think differently, right? Is everyone else following along with this logic? Systems of systems. Each planet is its own system. How we get there and what we put in between the planets, it's its own system. The space itself is a system. Okay? No confusion. So what did we do here differently? I said, this is my operational scenario for my customer. I need to plow better. I need to understand better. I need to cut better. I need multiple things to do with inside of that. How does it work? I just made you think way differently, right? I brought you up to a 3,000 foot level without confusing. That's what you do. You live here. Those guys, they live here. You can live in both. You have more power. You have understanding. But you need to look at this analysis side. Do you think you need all of this? No, absolutely not. No. Whoa. This is ugly, and I'll explain it. Okay? But what they did was they brought it all together. Why is that important? What did we talk about? Collaboration, communication, timing, save. They brought it together. Look. They took these operational scenarios, they met them, and they used what? Products, and they learned. Huh? Economic value. What did we do? Was this a success? I've already proven to, yes. The real video I can give you access to. It's very good. I was very lucky. I got to go to Germany and work with these guys on this. It was a lot of fun. I work with the US John Deere team all the time. This was great. We got to go to Germany, think about something totally different, and learn more about their business and how we can help them. How do you think I help them? And it's not tool related. How do I help them? I help them because of this. This is complex, eh? Can you even read it? I challenge. No. I said, no, we're not doing all of this. Why? Because it's too much. Systems engineering is already somewhat difficult. I'm trying to make it easier by adding modeling tools. And then, Jason, you're telling me to do this. No. I want you to do what's best for you and your organization. Pick the diagrams, pick the operations, pick the understanding of what's necessary. Because I want to go through a scenario. If we look at this, we're going to fly the warhead. Did we already see a video about flying the warhead? Right? We saw it earlier. So let's go through it. What is necessary to fly this? The pictures are up there. I'm just going to go a little bit deeper. Yes? What's next? If I'm launching, I've launched. What do I need to do? I need to find the target, right? Uh-oh. Yeah, good. How do I find the target? Huh? We're doing good. What's next? Oh, there's more. I'm not there yet. Wave sensor. What about this? What would be hard? You have mountains. We live in a mountain right now. We're pretty high up here. Is that not a problem? Making you think differently. Yes? What about next? That's the target, eh? I swore at you. I told you I'd get there. You swore at me, I swore back. I don't want documents. Right? We want to live in a digital world. AI is king, right? Does everyone trust AI? No. Should you? To an extent, yes. It's a tool. Yes. Is this a tool? Yeah. What about this one? Is it important? For sure, yeah. Is that part of operations? Yes? Okay, good. All right, what about this guy? Oh, most important and very important. All right, so think about those two terms. You guys are answering my own questions. I'm going to prove it to you this afternoon after lunch of why this is so important. That one word, maintenance. And then how all of this comes together. I'm going to give you a real life scenario using all of our tools at once. And I'll really just make your mind explode, and then you'll really yell at me. But wait a second. I want to understand this in the enterprise architecture because that's what I'm talking about for 10 more minutes. Okay? Okay. So let's break it down. These are my systems of record. Right? So the Navy, they're not in the room, right? They didn't want to come? Okay. We'll see them one day this week, right? So they own that, and you own this, and you own this. Right? Because this is communicating with that, it's communicating with that. Right? So you own this guy. So you're your own system. Do you play nice with these guys? Sure. Yes or no? You have an ecosystem. Exactly. You should be able to play nice. Why? Because it gets me to this. We're all doing the same mission. Without them, I can't fly it. Without you, I can't find it. Then, I can't destroy it. You have to work together, and that's the capability. How do I do there? Where do I go? It takes this. These are the key capabilities or characteristics that are necessary for you to work together. Think about it, systems to systems. We just proved it. Space, planet. We broke it down farther. Now, bring it into your world. You can't help the missile without your GPS. You can't help the Navy launch without communication. You must work together, and if you both have models, you work together. Right? Because you can describe everything. And you need the framework that takes you to another level. Who's lost? No one? Come on. Be honest. I'm that good? The US guys that good? No. Let's make it even harder. You're going to tell me you're not lost. You have to be lost now. This is the ugliest diagram I've given you today, because the other one I didn't explain. I told you to ignore it, right? But if we look at this, I'm telling you that here each layer has very key characteristics of capabilities that's necessary to be successful. Do you have to use them all? That is a question for you. You answer. No. Why? You do not need to use them all to get the point across, because if you use them all, it'll take you too long to get there. You don't need it all because some systems are not that complex to understand the movement of capabilities, of understanding the requirement of the system itself, on how it's supposed to communicate. Why? Because it's built off multiple languages. So I can be able to do more. I don't need them all. However, there are certain things that I might need 100%. Do I need a resource view? Probably yes. Do I need an operational view? Yes. Do I need a systems view? Of course I do. Do I need a mission view? What we call an OB1, operational view number 1? Yes. Where do I get that from? The highest ranker. He tells me what my OV1 is. Why? Because he's the mission. He tells me what it is. It's the pretty picture. It's the PowerPoint. From there, I can look at how do my capabilities go. Do I need to involve security? Maybe not yet. It's over time, right? Do I need a project view? No. Oh, 2 gone. We got 12. So 2, now we got 10 left. Okay. Do I need to look at actual resources? Maybe. Are they important? Yes. Are they detrimental to the program? No. Not to the architecture. So no, I don't need it all. I want to know and execute to what is needed at that time. And over time, you look at this. I hope I put it in there. Maybe I did, or maybe I didn't. And I'm going to show you why this proves to the point that you don't need everything. I'm really going to hope. Yes. I'm going to go back to it. Sorry. This is what John Deere did. Did they use all of it? Were they successful? Success is in the eye of the beholder, eh? Execution is to what? To do. The function of doing is providing. What are we providing? Data. Why is data important? It's a means of communication. Right? Still not lying yet. So John Deere was extremely successful with only using half of the entire UAF. Does this help you? I answered your question. I've proven to you that it's not about all you can eat. Unless you go to Carl's Jr. And if it's not all over the place, it shouldn't be in your face. That's the old commercial. Everybody remember that? Or is that the commercial still down here or no? So for us that grew up in the 90s, or from the 90s, sorry, the old commercial Carl's Jr. was, if it's not all over the place, meaning their bigger burgers aren't on you, it shouldn't be in your face, meaning you shouldn't eat it, right? But their burgers are pretty good. And I saw you guys have one, and I can't eat red meat, so I'm not going, but it was kind of cool. I don't have one in Dallas. Why? Because we have barbecue and all these other cool things. But this proves you don't need all you can eat. Use what you can. Use what you can control. Use what's important to the capabilities of the program. Does that all make sense? Yes? My friend. That's exactly. You never know when it is enough. But if you look at the way we teach the courses and we understand UAF when we talk to you about it, we teach you language and we teach you tool. You get the benefits of both worlds. When we look at that, we understand that, in my opinion, this is Jason's opinion, that we should always have a capabilities view. We should always use requirements. It's on the bottom. We should always have operations. After that, I don't care. Now, we're doing systems engineering. We're doing enterprise architecture. What do we need? We probably need systems view, right? Okay, so 4 out of 12. Okay, now, there's taxonomies. There's different ways we relay the data. It's meant for pretty pictures. There's different things you can go about utilizing the architectures to be successful. So when do you know that you're needed, when it's needed or not? As you learn the frameworks, you'll see what you have to put in and what you don't have to put in. what diagrams you must have and what not. Within this, the US DoD has mandated all contracts have UAF or systems engineering models within all programs. Does that mean you should do that? Maybe. Well, let's learn and then you make the decision, right? So why have healthcare not joined it? Why has industrial equipment, we've heard John Deere, why have they not said agricultural must use systems engineering or modeling? They haven't found the right standards bodies, right? We at OMG don't have an architectural standards body to implement certain types of structure or language design. We're utilizing SysML, right? We might have a working group that helps control or help within risk analysis and things like that, but it's not a mandate. How do we change that? How do we get the FAA to say we're finally going to leave our document process? We're going to go to a virtual twin, right? Or a digital twin. Well, how do we get there? We've showed them that MBSE works. As of last year, they've mandated all new programs with the FAA will use model-based systems engineering. Now, they're different. Like the US DoD, they said you're going to use CATIA Magic. FAA just says, provide me an MBSE model. They don't care what tool it comes in. There's the difference, right? You can learn a lot of this. We'll go back to this community. As I wrap up, is why is it important? The answers are here. It's not just me. Go to the experts. Do I consider myself an expert? Not at all. Why? Because I'm continuing to learn. Do I want to prove to you that it works? Absolutely. Do I feel this could be beneficial to you? 100%, if not more. So, why? I used the quote earlier, if you build it, they will come. If you learn it, you can implement it. If you implement, you can be successful. If you collaborate and communicate, you're already improving. Those operations and capabilities that are necessary get you to success. If we do that together, you build a better community. You can attack this from both the top and the bottom. What do I mean? The top is you guys. The bottom, not trying to be offensive, but the university, right? You train the engineers move into career is here. Huh? Oh, career is there. It's a whirlwind. Create a future, right? Architecting the future. So then go back to my original question and then we're done. Can you architect the world we live in? Yes, one element at a time, right? I kind of proved that. So we'll show how all of this really works in a live demo after lunch. Thank you for your time.
Se queda, él se va a quedar. Con el Contreras, sí.
Porque lo vamos a entrevistar después. Si quieres, ahora. Sí. Yo le voy a decir después, para que quede disponible. Muy bien. ¿Cómo estamos? ¿Cómo están esos ánimos? Después del café, el té, los sanguchitos, ¿ya volvieron la sinapsis? ¿O se quedaron en alguna de las cajitas de la arquitectura unificada? Me recuerda a mis épocas antiguas de arquitecto de sistemas. Bueno, muy bien, como continuación, tenemos el agrado, ¿no?, de contar ahora con la presencia del general Luis Sáenz, como les había dicho, ¿no?, director nacional espacial y jefe del proyecto de Sistema Nacional Satelital de Chile. Estuvo esta mañana, ¿no?, con rector, decano, estuvo en esta ceremonia en que firmamos, ¿no?, el acuerdo para trabajar en la nueva carrera de Ingeniería Aeronáutica, pero en su apretada agenda nos puede acompañar el día de hoy, así que lo recibimos con un caluroso aplauso y le dejamos el estrado, por favor. General, todo suyo. Aquí está.
Muy amable, gracias. Bueno, muy buenos días todavía, nos quedan unos minutos antes del mediodía. Y deseo aprovechar esta instancia, ya que no pude estar en la mañana, para compartir con ustedes algunos conceptos y reflexiones en el contexto de por qué estamos realizando esta actividad. Primero, agradecer a nuestro dueño de casa por la oportunidad de reunirnos acá. Ya vamos a tener, a partir de esto, otras áreas donde probablemente vamos a poder seguir trabajando en equipo. También a So por traernos este conocimiento. For the first time in Chile, I know. So you are here almost in the Wild West. Okay. So thank you for being here and thank you for the support. Y particularmente a todos aquellos que aceptaron esta invitación. Tenemos personas de la industria, personas de la academia, de la defensa, y eso es lo que buscamos acá. Esto se enmarca en la implementación del Programa Espacial Nacional de Chile, que tiene como primer y gran objetivo desarrollar la industria aeroespacial. Una industria que hoy día hacemos bastantes cosas en lo aeronáutico, pero en lo espacial tenemos muchos desafíos y que tiene un vínculo importante con la información y con el ámbito cyber. Para hacerlo nos dimos cuenta de que el proceso requería varios ingredientes que hoy día no teníamos muy consolidados, y algunos nos faltaban. Para fortalecer la industria, lo primero que tenemos que tener es la capacidad de desarrollar tecnología. Y eso hoy día en nuestro país está al debe en muchas áreas. ¿Cómo hacer entonces que nuestro país avance en esta capacidad para desarrollar tecnología, entendiendo la tecnología como herramientas, como soluciones que las personas generamos para dar solución a los problemas que tiene la sociedad? ¿Y cuál es la problemática que enfrentamos en el espacio? Particularmente que el espacio se transforme en un factor y en un recurso que podamos incorporar en la ecuación de desarrollo nacional. Por eso necesitamos que esta tecnología nos permita acceder y utilizar el espacio para que efectivamente lo incorporemos como un factor de desarrollo nacional. Dicho eso, resulta hasta ahí fácil teóricamente hablar de cómo desarrollar esta capacidad de generar tecnología en el país. Para hacerlo, nos dimos cuenta que había dos ingredientes fundamentales en donde necesariamente tenemos que hacerlo en un vínculo con la academia y con la industria. El primero es que necesitamos incrementar la capacidad de generar conocimiento. Ese es el primer pilar en el cual el desarrollo tecnológico puede ser una realidad. Y esa es la labor que han tenido desde Platón las universidades, ¿no es cierto? Que es crear y sistematizar el conocimiento y poner el conocimiento a disposición de las personas. En ese contexto, entonces, que además creamos la carrera de Ingeniería Aeroespacial, que se inicia el próximo año como currículo en la Escuela de Aviación, y probablemente más adelante hagamos otros cambios en otras áreas de formación más técnica de la Fuerza Aérea, en un proceso también que hacer muy colaborativo con la academia y con la industria. El otro pilar es la promoción del talento. O sea, para desarrollar tecnología necesitamos generar conocimiento, pero para generar conocimiento necesitamos promover el talento, que es otra de las áreas donde las universidades tienen un rol fundamental. Y por esa también razón es que hemos de programas escolares espaciales hasta la carrera de Ingeniería Aeroespacial, y más adelante probablemente, recién hablábamos ahí con ENAER, los doctorados industriales que necesitamos incorporar en distintos proyectos, incorporar otras industrias en el desarrollo de doctorados industriales. Con esos tres elementos, efectivamente, nuestro país puede avanzar en crear este puente entre la ciencia básica y la ciencia aplicada, que es el TRL 1, 2 y 3, y avanzar de manera correcta, concreta, en la capacidad de los TRL 4 y 5, 6, que es ahí donde específicamente el Programa Espacial Nacional de Chile pone su énfasis. Y por eso que este es un programa eminentemente industrial, eminentemente científico, eminentemente civil, porque vamos a desarrollar capacidades primero a nivel país. ¿Cómo tomamos esas capacidades y las utilizamos en beneficio de la defensa? Es la segunda etapa del proceso. Pero lo primero es la creación de estas capacidades. Por eso, iniciativas como esta, en la que desde los procesos de formación en las aulas, desde un arquitecto a un ingeniero, que podamos diseñar desde un lápiz hasta un satélite, bajo un sistema de ingeniería como este, y que lo podamos certificar, es algo que es fundamental dentro del proceso de desarrollo tecnológico. Ojalá que dentro de los nuevos proveedores de la industria, que van a nacer fruto de este proceso, tengamos, y disculpen lo simple, un proveedor hoy día en Chile que fabrica ollas de aluminio, pero que incorpore este sistema y que logra certificar sus ollas con este mismo sistema que más adelante le va a permitir fabricar partes y piezas de aluminio para un satélite y que esos elementos lleguen al espacio y formen parte de la cadena de suministro y del ecosistema nacional de proveedores, no solamente de la industria nacional, ojalá también de la industria internacional. Entonces, partir en el aula con talleres que le permitan a los alumnos de distintas carreras aprender y conocer y utilizar esta herramienta durante su etapa de formación es el primero de estos grandes objetivos que tenemos hoy día en este taller. Es cómo incorporamos esto de una industria que produce tubos para la minería hasta ollas, efectivamente logren incorporar este tipo de herramientas, logren certificar sus productos y servicios y así tengan la aptitud para más adelante formar parte de los proveedores de esta naciente industria aeroespacial. Finalmente, y como tercera etapa de lo que tenemos previsto, es que la capacidad de investigación y desarrollo y la generación de patentes, que lo hablábamos con el director recién, que es el gran objetivo que tenemos como consecuencia de este proceso, aprovechemos estas nuevas capacidades que va a tener el programa espacial, específicamente primero en el Centro Espacial de Santiago, donde hay una gran capacidad de supercómputo, capacidad de almacenamiento on-premise, acceso a través de Reuna, información de calidad que nos va a permitir alimentar los distintos algoritmos y los distintos procesos, sea efectivamente el camino con el cual llegamos a generar estas patentes. Y efectivamente ahí llenamos este gap que tenemos entre los TRLs 4 y 5 y 6 y podemos aportar con una patente que va a derivar en un producto mínimo viable, en un producto con valor de mercado, en un producto que nos haga como país formar parte de la industria aeroespacial internacional. Por eso que agradezco a la Universidad Adolfo Ibáñez, a Dassault Systèmes por este apoyo y la asistencia a cada uno de ustedes, porque aquí estamos efectivamente poniéndonos metas muy, muy interesantes. Pueden sonar muy desafiantes, para algunos un poco irrealistas. Aseguro algo, quienes estamos trabajando en el programa espacial tenemos la convicción que esto lo vamos a lograr. Y con esa convicción es que termino mis palabras agradeciendo e invitándolos a formar parte también de estas distintas iniciativas que vamos a implementar, en donde vamos a trabajar juntos el ámbito público, la industria y la academia, que es la única manera en cómo efectivamente vamos a poder construir esta industria aeroespacial nacional. Muchas gracias.
Bueno, muchas gracias, general. Yo creo que es importante tener en cuenta que cualquier realidad antes de serlo fue una idea, ¿no? Hay que concebirla. Como yo siempre le digo a mis alumnos, los países y las personas no limitan con su geografía, limitan con sus paradigmas, con su capacidad de imaginar y de pensar. Y por eso, ¿no?, tenemos algunos países que tienen todo tipo de restricciones y están en los primeros rankings de la OCDE, y hay otros que tienen todo tipo de recursos naturales y están en los últimos de la OCDE. Y los arquitectos de esa transformación están aquí, ¿no? Son las personas, y es importante la capacidad que tenemos de imaginar, pensar, convocar, articular, que es justamente la idea de este tipo de actividades. Así que, nada, muchas gracias, general, por estar aquí hoy día con nosotros, por supuesto a todos ustedes, y para dar continuidad a la segunda etapa, ¿no?, de este seminario de hoy, vamos a dejar nuevamente a Jason Wilson para que entremos específicamente en casos aplicados que podamos tangibilizar de qué es lo que estamos hablando, esta conexión con diseño y arquitectura y aplicación e impacto, ¿no?, que son dos elementos que necesitamos garantizar que se integran perfectamente. Así que, Jason, please,
Yeah,
it's your time now.
I'll continue.
Okay.
Is everyone bored from this morning? You still awake? You still want to listen? I'm a long way from home, and again, thank you so much. It was kind of nice. I just looked at my phone for the first time because I left it over there, and I got a picture from my wife and daughter saying good morning. So I know my daughter's at school for another hour and a half until she can look at her phone. So I'm gonna ask if you don't mind. I'll take a picture, kind of proving to her that I'm here. I'll make sure it's only between us girls. Thank you so much. Now she can see that I actually have a job. Okay? She's like, "Oh, Dad, you're always gone." Well, you know, I have to make sure the dancing is taken care of. She is a competitive dancer. When we relate our everyday lives to the architecture, do we need to dance around the information? Maybe, maybe not. So this morning we talked about the basics of MBSE and systems engineering and that importance, correct? And then I said, well, I want to blow your mind and say everything I told you was a lie and talk about architecture even higher. But then I proved to you that I can make it work together. So now let's actually see it in a real life example. What I'm going to talk here through comes from a paper written by NATO. Remember, we talked about a architecture framework that's built into UAF and where it goes and how it gets there. So we're going to use a variety of tools, and I'll explain it at the end. But I'm showing you how enterprise architecture can be used to understand maintenance, right? I told you to remember that one word, the maintenance of aircraft. Trying to relate it to you guys the best I can. Within there, what's going to happen? So I need to take a step up a little bit. I'm going to skip this one because you guys already heard what Dassault Systems was. But where does it all come from? I don't think I explained it well enough this morning, so let me explain it one more time. Solutions are made from standards. Those languages help us execute the data that we want inside of tools, regardless of who makes them. We look at tools and frameworks to help us move forward in our careers and in our engineering program or project. When we look at that, in this example, we're looking at all of these in one single solution. Multiple tools, but one single solution to where you were trying to go. In this one, we look at it, it had to start somewhere. Who's 40 and older? I'm not trying to embarrass. My hand is up this time. Okay? I know I look like a young kid, but I'm not. We have to look at where CATIA came from, right? So we look at that. Within the growth, we do a lot of simulations. But where I'm going from is we all started with those documents I complained about earlier, right? We want to get into that digital world, utilizing architectures to get past it, to make it more effective and more efficient, making things, the communications and all those come to life. Well, now, who has a Tesla here? No one? Good, I don't have one either. I don't like it. But when we come to the word autonomy, it's becoming our everyday life. Why? Because we as humans are lazy, especially us Americans. Why are we lazy? Because we want things to be done for us And we look at the generation of change. Is change hard? No, change is easy. I finally lied to you. Right? Change is not easy. But can you change? Can you change for the better or for the worse? Yes, you can. When we look at change, each industry has made changes to be successful. Aerospace and defense has driven change for success. It doesn't matter what country, doesn't matter what division, you've made changes to be more effective. Those changes are around you every day. You choose to make them or not. Those are decisions. Those decisions impact your life. That helps you become a better engineer or a better person. Why? I said it earlier, we're all unique. When we understand that this change and these challenges have been put for us of where we're going, we have to look at it from an architectural view. This is a lot, and we'll break it down. And we'll show it in action and how it's broken down between the life cycles of knowledge within what we're trying to accomplish within all of the total system. Does any of this resonate from the presentation before the break? It's not repetitive, but it's direct. Right? Concepts of operations. Who owns this? Who owns the picture? I talked about it. I called it an OV1, correct? Who owns it? These guys? They own it, right? Who owns the architecture? They do. Who owns the behaviors? They do. Who owns the traceability? Y'all do. Am I making sense? But when we build up on it, within these programs, we have to understand the middle layer just as well as the top layer, right? Because in this drone, it is something. There's use cases, there's architecture, there's behavior. But wait a second, those are just architecture capabilities. What about the physical? What about what I call downstream engineering? The CAD, the electrical, software, fluidics, all of that. What about it? How do I keep continuing to communicate with them? I will show you today. I'll make your head spin as much as I can because that's my goal. Because we have to look at where does it come from and where do we want to go with it. Who is sick of hearing about twins? Who is a twin? Like an actual human twin. Who's a twin? Anybody? No? My wife's a twin, so kind of lucky, kind of not. I don't know. But are we talking about the human twin? How many twins are in the world today? I'm confusing the heck out of you with 3 on the board. But the last one is even more, so I added a 4th. Why can't we just say the 4th? Why do we have to say that there's a product twin, a manufacturing twin, a services twin? Why? Is it important? Maybe. Maybe. It sounds great, right? What was early 2000s cloud was, everyone needs to go cloud, and we've been doing cloud for years. What makes it so important today that cloud is cloud? Right? It was the buzzword. When we needed to do .com era, and then cloud, and now we're at virtual and all the different twins. How do we execute to the twin? Well, you have to leave documents to get to twin. Can you document the twin? Can you have a twin of a document? Does it even make sense? So I'm going to break this down visually, if you can't see everything, because from today, where do we live? On this, not in Chile, I mean on the diagram. So if I look at it, there's as needed, as specified, as designed, so on and so forth. If we talk about the architecture, which ones do we live in? There's 2. What do you know? Remember, first rule, participation. Second rule, ask questions. Third is try to stump me. Okay, I'll continue to make you laugh because when we look at what's going on, we live in the first 2. So systems engineering, software engineering, architecture design, we live in the first 2. We need to build the as is. We get to the as specified. They drove us there, right? Made your life happy. Then we go farther, right? What about assembly? What about manufacturing? How do we get there? Should we just dive in because we've been perfect at it for so many years? Is the process perfect? Is the process executable? Do we know that? Have you noticed I have only been asking you questions? And I'm still getting no answer. Now I don't expect them. But when we look at those questions, it gets you to the results. Do you, sitting in the room, have the answers? That one you can answer. You have all the answers. Why am I here? Ah. Okay. Well, I hope I'm not here to get you answers. I hope I'm here to show you that there's something fun that you can do in your job to be successful within the program that you've been asked to do. Using tools, languages, methods, functions to execute correctly, right? I'll bring you my experience. I'll bore you. After you're bored, you'll ask questions and we'll keep moving forward. But if you look at them, watch the videos, each one of them relates somewhere, right? So it's not just my words, it's what you're seeing. What about here? Think about the satellite. It's in flight. It means what? We're in maintenance or we're in operation. I need analytics, continuous, correct? Isn't that a large amount of data? Should you not have a federated data? We need to understand where all the data is going to reside. How do I look it up? How do I understand it? Where does it come from? Remember, most of this talk is questions. You answer the questions for yourself. You be successful. I can't make you successful. I can only give you the information that's necessary. Let's talk about this scenario because I like this one. It's a lot of fun. The document says that they had an issue with maintenance of supplies inside of all of NATO. But then take a step back. What is NATO? Does everyone know what NATO is? Okay. So within there, how do I make sure that enough supplies are being built, delivered, and executed to aircraft maintenance? That's what I'm going to show you. It all started with what? An architecture. It's all explained, right? We have to understand the vulnerabilities, which is our V&V process, right? We have to predict it. We have to understand what could happen, what will happen, what won't happen. How do you get there? What math is important? By the way, this is one of the harder talks that I have to give because it's 80% questions. It's not statements. You have to think for the next 41 minutes. If you can't think with me, then you fall asleep, you look at your phone, you find the email, and then you say, this guy's an idiot. And that's okay. I'll wear a red nose next time. But when we look at the logistics of what we're doing and how we're getting there, we have to understand the view, the map. What is it? Why are we getting there? How do we understand it? And what I like in the middle, the operational availability. We have to keep the aircraft flying, correct? So think about that. If we're keeping the aircraft flying, in this case, these are actual aircraft. In your case, think about the satellite. How do I keep it flying? What are my communications? What are my avoidance? There's a lot of junk up there, right? The hardest mission of all of the world right now is how do we clean our own space, right? Our own level of entry or low orbits, high orbits, long orbits, right? We have the difference. There's three. Well, how do we clean it? How do we avoid it? How do we put more fuel into the aircraft so it can avoid? How do we make sure we don't lose the aircraft? Same with this. If there's problems with the aircraft, I lose the aircraft. How much is an average cost of the aircraft? Far more than all of us combined in the room. Yeah? Still not lying, right? So, at Dassault Systems, we believe if we help you with this virtual twin, it starts with what? The idea, the architecture, the understanding, and we get all the way through. I'm done. But how did I get there? How do we ensure that where we go with the data is executing to your plan? How do we make sure the data is connected? Does that make sense? Right? Have I made you think more than I made you think this morning? Okay? So where should we start? With number 1, of course. Okay? With number 1, we'll start with the video in a second of the actual model in execution. But I'm simulating for analytics since I've already built my architecture. But I want to break the architecture down just a little bit, and I'll use this screen over here since you guys don't matter. When we look at the diagrams, I set it up very easy for if I give you this model, you can walk through it. Right? You want to look at mission? Cool. You want to see what the architecture of the MCO is? Great. What about this one? What about the missions, right? I walk you through the different aircraft type or different aircraft scenario. Pretty basic. Did I confuse you? Nope. Okay, but now look at this. And you'll see this in the video. That's a lot of boxes. It's a lot of lines. But what I'm showing, and I'll describe it, is the interfaces. Why are the interfaces the most important part of what we're doing within these architectures? Yes? Yep. Yes. Correct. So when the architecture gets too complex, how do we deal with understanding the notion of what is right and what is wrong anymore, right? If you break it down into small chunks, where you model one system at a time, it's easier to understand. What did we say earlier? Can the human understand everything? No. That's why we want to model, right? I can't ingest 20 different documents of 500 pages apiece. Well, I can. It'll take me a year, and then my salary's wasted, and blah, blah, blah. But if I put it in a model, I could look at it pretty quickly, and I can add links or traces to where I can find key information very fast. But it still doesn't answer your question. Your question is, if it looks like this all the time, it's too confusing. Yeah, but you own this. Each one of them own either this one or this one or this one. They're responsible, manage up. It lowers the complexity and for you to make better decisions utilizing tools to look at the analytics deeper and darker if the information is in the system. Yes? Aha. Yep.
So usually in these complex systems, humans are made
Yeah. Absolutely.
there's scaling.
Yep.
There are many faculty skills that need to be involved in the headcount.
Yep.
The number of people working, skills, decision making.
It's an awesome question.
Finally coming up with a system that involves machines and pieces that people deciding, people being involved, coordinating, planning.
Yeah, I got you. Yeah, absolutely. It's not in this model to the extent that I'm showing, but let me answer your question. So the personnel view of UAF allows you to pick everything from your organization, from a top-down structure, right? Just like an organization chart, but it's very detail-oriented. And we'll talk about divisions or sublets. What is a post? Why is a post important to a particular individual? What is the rank of the individual and those types of things, right? Are you a senior engineer? Are you an engineer? Are you a junior engineer? What compliance competencies do I need? What certificates do I need? You can capture this. How many years of experience do I need? What are my strengths? What are my weaknesses? Right? What am I able to do? For instance, to answer the question even in more detail. Yesterday, to the team, I showed them my organization back in Dallas. I have 18 people. I cover all systems engineering tools at Dassault Systems from the CATIA brand perspective. So we are broken up into 12 brands. I'm part of CATIA. I lead the division for systems engineering. I have 51 tools that I have to know. Is that too many for one person? Yes or no? Yes. Do I know all 51? Absolutely not. So I built an enterprise architecture of my organization. I showed it to the team, and I showed them where my gaps are. I have 2 open headcount, and I'm going to try to find a new person, a new engineer, to fit what I'm missing. The analysis that I did was I'm light in software engineering, and I'm light in enterprise architecture. I have 3 people that can talk about enterprise architecture. I have 1 person in NAM that can do it. Where's my problem? I need to hire. Yes? Yes? I can't do it. I can talk it. It gets boring. But I can't do it. I can show it to you. I can walk you through it. I can demo it, but I can't do it. It's not what I do. My job is to show, tell, execute, go into the tool if I have to. So, real life experience. I now know I need a software engineer and an enterprise architect. I use the tools that we want you to use with my organization. I also use it live normally within customers. I will do an architecture of tools live, and then I'll give it to you. I know all the interfaces. I know what tools we interface with. You tell me your environment, I give it back to you. You have something to start with. It helps from a personnel view because then your team then can execute to those integrations and those data points. And if those data points then come back to what we're looking at, those interfaces become even more apparent and more valuable to the person reading the model, which is your bosses, right? Or your leaders. I don't like the word boss. Does anyone else like the word boss? No. I hope that I'm never a boss. I hope that I'm leading people to success. Through that success, we look at this within the video. It's plain, right? Yeah, good. So I'm going to walk through the aircraft. I'm going to look at the decomposition of what is available for the aircraft and where the aircrafts are and will be over time. So they're in the hangar. They can do all of these different things. Right? So you see, I'm going back and forth. These are the missions that a particular aircraft can go through. This is where they lie. I guess I should stop. Yes. Okay, good. So, daunting, yes or no? Yes, it is? It's just because you can't read it. No, it is daunting, right? But what we did here is we showed what scenario could happen in the order of operations. Who's talking to who? Go back to the missile from the last one. What did I say? I launch it from the Navy. I then pick it up with GPS. It has its coordinates. It finds its target. Blah, blah. Right? Same thing. Oh, yeah, but it's not a missile, Jason. It's a fleet. Okay, well, fine. Pick one aircraft. Where does it sit? Okay, it sits in this airbase or it sits in this airbase. Where did it come from? We use this with Dassault Aviation. Why not? It's a French company. We're a French company. Makes it easy, right? You think the US was going to give me this data? That's not possible. Right? That's what the white papers are for. We interpret the white paper to make you cool designs, right? But now it makes you think. If I know that my aircrafts are in these places, and I have a way to communicate with somebody to help me, whether that's an aircraft carrier or a base, how do I get them parts? How do I ensure the maintenance of those parts? Why would I not do a trade study analysis of how everything comes together? That makes sense, right? So if we look at it from that high level again, I've now broken it down even simpler to where I'm looking at the operations of what's talking to what. Okay? Yes, it's a lot of data on one screen. I don't recommend doing it this way, but there are times you have to. Why? the picture's worth 1,000 words, correct? Is this the system of record? Yes or no? What you're looking at. We're understanding the operation and the simulation, but is it the system of record? No. Why? Because it's just a pretty picture. The system of record is in the containment tree that holds all of everything, all the relations, all the capabilities, the functions, not yada, 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 the requirements, capabilities, yes. So what I did was I simulated this to get raw data to ensure everything is connected. That was the first thing I did. Then I said, is everything capable within the capabilities that are in the model? Yes. Okay. What I only needed to show you was it's simulatable. In the tool, anything that is a behavior can be simulatable. Okay. So if I have this simulation data, what do I do with it? Nothing? You can keep doing more analysis, right? So what I want to do is I want to take it out of the architecture and I want to give it to a little bit stronger simulation tool to do a lot more scenarios, right? So within these logistics, I'm going to break down both requirements and my, what we call an IBD, internal block diagram. So what system's talking to what, and understand why that data is there based on the requirements. From there, I get my analytics. We'll go through there very quickly. So within this, I build out my schema. Within that schema, I can look at the architecture. Remember, I've already showed you architecture from Cameo or CATIA Magic. I then export it, and it stays intact. I'm just reading it in a different form, and then I need to run analysis. This is true analysis of what's going on between aircraft and potential parts that could be breaking throughout its life cycle. And we identified, because we've been flying these for so long, what parts are most vulnerable. We can see that. So from here, as I look at everything is true, there's no way. The number one question I ask my team when they talk to a customer is, why don't you ever talk about the pros and the cons? Why would I talk about things that break? Why not? They're going to find something that's broken. Not all tools are perfect. Not all solutions are perfect. So if we look at this, all that is true, but it was validated. That means the architecture was true. That means we did something right. What were the gotchas along the way? I can tell you some of the gotchas where there was redundant requirements. This tool identified the redundant requirements, and we got to change them so that the simulation could go on. Very effective way of doing things. And you can see here, I'm now going to go to a full nother level. I'm going to take the data, and I'm going to go into the 3D Experience platform and rerun it with actual data that we can pull from the web. Within there, I can then run yet another simulation. You can see the theme in this one, simulation. But where did it start? From the architecture of where the aircraft could be or should be, how many aircraft, how many parts. Now I can modify that. Is this making sense? Okay, so if I'm modifying those parts and I'm understanding where my supply chain is, why is this important? Because if we go into battle, I need to make sure that if I have to keep them flying. If I keep them flying, then where? I can keep them operational. But if I keep them operational, I need to know what? I need a twin of my factory, do I not? Because I need to know where the parts lie, how long it takes to get there, how do I communicate the human factor, that we needed to make sure that there was enough people at that particular base that can make those changes to the aircraft. Doesn't that become a factor of change? Becomes the challenge? We have to look at this from every level of experience and understanding why it's important. What is the difference between real and virtual? Virtual is going to be our scenario, right? Our building, our ensuring that we're doing it right. Isn't that your number one goal? Make sure if we build it, they will come. If you build it, it will fly. Did I meet the requirements? Did I meet my spatial execution? Is the battery correct? Will it last for so long? I just gave you all of your capabilities. I hope you took notes. Right? Let's look at it. Oh, here's my factory. Not hard. It's my virtual twin, right? I can find out where in the factory certain parts and capabilities are there throughout. Look at this. I now have everything that I need when I put the data in there. Yes, it comes from a file, right? The file maintains that data. We just visualize it. Within the visualization, we can take it to a whole other level with the 3D Experience platform, with a tool that we can then run the numbers against where the flight plan is. Why? Execute, understand, make changes. Wait, so there's that word again, change. Are you okay with change? That's why we do this. We do this to understand where we're going and how we're going to get there. So, what would we do? What if scenario sounds good to you? Is that what you would do? Maybe? That's what I would do. I mean, that's what we did. So, if we do what if scenarios, I want to make it good or bad. I want to take data, bring it into a simulation, and change it. I want it to fail. I want it to be successful. I want to identify the exact part it's in when it will fail. I can do that from the analysis. Could I do that in the model? I could, but this is much faster and much better. Look at the middle graph. It dies after so many flights. I need that part. Where's the part? It shows it. There's only 6 available, and now I have 0, and in my internal stock, I'm minus 10. That means I'm not manufacturing it fast enough. Who do I need to go? I need to go yell at a supplier? Do I need to 3D print my part? Will that help? What is that scenario? I asked the team when they gave me this for this meeting, I said, did you do analysis against 3D printing? And they said no, and I said, why don't I have it? Well, we never thought of that. Why not? I made them think right away just by their presentation to me. That's my presentation back. Would you have thought of that? Is 3D printing that important today? It's becoming more important because it's faster. Is it structurally sound? We don't know. Depends on the 3D print. Will it be executed? How do we tie the 3D print job back to the architecture? Okay? We think about those scenarios, and the logistics of optimization becomes key. That optimization really becomes key when I need to show my management that we're 100% across the board. Is that possible? It should be. It could be. We need to execute. But it takes the ability to understand what we're working with, where it came from, and how it got there to get to 100%. If we look at the scenario, we're going through the data, look at what changed. The stock has changed. Now we know we're never going to go to 0. That's awesome. But now we will. All we did was look at one change. So, but it's farther along, right? I have parts. I can fly 20 more times than I could before. Is that a positive or a negative? But it's a positive, very much so, right? But I still have a negative because after so many flights, so many aircraft can't fly. We have to go and redo these scenarios because it becomes essential for the cost, the understanding, and what's driving it. Is it just the analytics driving it, or is it the architecture should be driving it? Is the architecture wrong? I have to ask these questions. How do we know the architecture is right? Behavior of the system, exactly. If we see an anomaly in the analytics, we should go look at our system design and our architecture to ensure it's correct. If it's not, we have a problem. Why do we have a problem? Can we fix that problem? Yes. Why? Because we built it in the architecture. And we can then rerun everything we did. And we get to the same scenario that we just did. And within that, look at this. We have the success factors. Okay? So we built this particular example off a white paper from NATO. We then went to Dassault Aviation and the French Air Force and to NATO themselves and said, look, we took your document and we really created something you should look at. And we went to the maintenance teams and said, what do you think? The chief engineer on the maintenance team said, I love it. How do I get it? What do I do with it? How do I learn it? What was the problem? It was a top-down approach. Only person that loved it was the head guy who understood it. When you get to the worker bee engineers, they had no clue what was going on, and all they saw was a tool was going to take my job. After 1 year of convincing, They finally saw that it wasn't taking their job, it actually helped them. It made them understand their processes. It made them understand what was going on. It made them think differently. Did I ask you to do that? Think outside of our box. If we do that, we'll be successful, right? Are these success factors? There's failures along the way, I promise. Even with our tools, we found a bug on how we interpret some of the data on our own pilot program. That's a good thing. It makes it easier for you guys. But it takes time. We have to put the effort into it. It's not just about one individual doing this. This was a 4-man team. 4 people built the whole scenario. How many people do you need to do what you need to do? I don't know. Think big, but start small and evolve. If we do that, you'll be successful, I promise. All right, so I did want to talk about the tools that we use because at the break, some people asked. So for this, I threw the slide in there just so you can see. Is that overwhelming? No? No? Do you have to learn them all as a single individual? No. Should you be an expert in reading all of the data from the different tools? You should be at least able to read it, right? If not, the tools are broken because they're not readable. I can tell you, I just showed you everything. Could you read it? Could you understand the story? For the most part, right? Well, you tried to, right? This one's a little quicker. But when we look at the architecture, the communication, the collaboration style, the execution of scenario, requirement, decomposition of understanding, finding redundancies, and then showing how all of it works together. Well, voila. Here's the paper, and I can give it to you as well. So anything that I ever present, this you see me again, you can have. I'm not hiding anything. My job is to ensure that you find it successful. Okay? Very good demonstrator, good information, and it's a big file, so I have it in a zip, and I'll give it to you. Okay? All right, if the internet is working, I will do one more. Is anyone done with me yet? No? Come on. You guys are too nice. Yes. It's in there. I didn't talk about it because I personally don't understand how they used it. So it's better for me to talk about it from let the paper and the video talk about it, because if I lie, then the talk is unsuccessful. But it is embedded into it and how they got the data analytics to be proven with mathematical equations and some other things of where and why they tied everything together. Does that make sense? So most of the data we get is real, of what we find or what we're trying to execute toward. But on that one, it was just about a paper, right? And how we turned a paper into a demonstrator to look at gaining ground within a particular customer we weren't in yet, right? So we are big in Dassault Aviation, don't let me lie. But within maintenance, no, we're not there, right? We created a scenario that could help anyone that's doing maintenance understand their aircraft and their vulnerabilities of the maintenance and part distribution and that supply chain. Supply chain's a big thing. I will say that I've been in very little meetings that supply chain actually shows up. Should supply chain be part of a meeting? I think yes. Sure. Yep. Yeah, great question. So the question, if you guys didn't hear, was if we make changes throughout the design process, how do we ensure the data is connected throughout it? So one of the things that I recommend when you do design reviews is you do them 2 weeks or every 2 months, right? Depends on the detail of your design review and what you're looking at. Are you doing a CDR for requirements? Are you looking to a PDR? What level of granularity do you need to get to? And then you know you have a stopgap, right? When you're doing analysis and you're making those changes, they affect everybody that's touching it, right? So we hope you don't find those vulnerabilities, but you do. That's the point of doing the analysis. That's why we look at a virtual twin, a digital twin, of understanding what is good and what is bad. And from there, so on requirement review teams, our requirements reviews were every 2 weeks before a PDR. Then on design review teams, they were every month. And they were normally 2 days long. So you see those changes every month, and you can make those adjustments. And normally, in this scenario, what we showed, you should be able to do it because all the tools are connected. If all the tools are connected, and we find that vulnerability, you can say, hey, I made an update, why don't you try it? And you can go through it there. That's why they're 2 days long in those designs. So being effective, it shows how all the tools that I'm going to walk through real quick is helping you from a senior level understand what is going on from what they're building or from what they're building. You should be able to see that in almost real time of the understanding. So it's actually a really good transitional question to this. What I'm showing here is the 3D Experience platform. I'm showing you what? The architectural, right? I broke it up into 4 layers, right? Use case design, requirements in the right, the structure of the CubeSat, and then the behaviors of the CubeSat. Okay? The point of this is to really show the value of traceability, requirement development, or enhancement to the downstream. So the requirements live inside of the architecture. I then bring it to 3DX and use it and enhance and move forward. And then I can ship it back if I have to. Very positive, okay? So within here, I look at my requirements, decompositions. I look at my different specification documents of what's necessary, both in the upper left and the right. I can see the textual form, and then I can see where it is on the model itself. Right? So all I've done is architected out all of the different requirements that are necessary for what we're showing today. Pretty clear so far? Ah, good. Makes it easy. All right, so from requirements, we get to that bad word that I don't like, but it shows that we have traceability. Now, I don't have a mouse, but I will try. Yeah, it's okay. If you have one, that's fine. But let me explain this while my friend gets me a mouse so that I can zoom in. If I want to look at, and I need to let it sync one time so that I potentially can show you the value, is if these are all my traceability, what we call nodes or objects, where is it touched and how does it touch it? You will see in the bottom right in the actual CubeSat physical design that those are linked. Why is that important? It's important to see consistent traceability from the physical part back to the architecture. In the US, I normally go a little bit deeper and I show, so especially on the military side, we have RFP. RFP ties into what? Execution from the OEM. Then the OEM I can put in here, and I can see all of their different architectures. I can see everything. The architecture's on the left. Okay? Within that architecture, I then have the ability to show how it's connected to the specifications I've built. From there, I can see that it's in my functional side. I can then look at it even deeper. So this is pretty high level, but you have a CubeSat BOM, and then you have a deeper BOM, right? And I can see where it's connected and what it's connected to. So end-to-end traceability at your fingertips. All you do is add the data. Most of the data already knows each other. Some of it is manual, I'm not going to lie. The value here is that if I pick a particular part, it should, might not, because I didn't have the internet all day. If I pick something, that it should change where the logical is. Oh, there he goes. It worked. Well, it worked on one screen. Is that I pick the higher BOM, and it should show in the picture, and it should show all the way back to the architectural design. End-to-end traceability necessary within. Question? Yes, sir. It is a real CubeSat that it has flown. This is part of Dassault's, I think it's ready to fly. We've added to it a little bit because for demonstration purposes to show some physical decomposition on the CAD side. We've shown a couple of capabilities from an integration with the BOM from a digital thread, and I'll show that here in a second. So is it a real? It's a real CubeSat. And really what I look at it for is to show all of the different ways you can connect data. And that execution of data is up to you as the user. Go ahead, next question.
How long do you create this demo?
So on the architecture side, it took me 2 weeks to recreate what I saw. Okay, so I used a template from the object management group in the CubeSat working group. They have built an architecture framework that I can build my CubeSat to. It's out of the box. Yes.
How long would it take for an engineer to reach this kind of
So the skills on everything I've shown today?
Yeah.
So this was made up of three. So I got yeah. So I have 3 engineers on this project. I have a systems engineer, which was me and someone else. But if you think of 1 FTE, I had a CAD person. I had an electrical person. The CAD person's a hybrid. He's like a jack of all trades. He's actually part of our CATIA and our SolidWorks, of course, our Novia side. He's a what we call a champion in those products. So he knows them very well. That's 10 years of experience of those products. I have over 20, so I helped within the architecture. That is not my architecture model. I did mine differently, but in the demonstrator, it's what you see. And then the CAD side, right? So because my person that works for me, he's amazing. He was able to bring in my SolidWorks BOM. That took him a week to recreate some of the SolidWorks parts that he needed. And then another week on the Creo side, we used another third-party tool that allowed us to look at that in a better light. Because what I believe in, some may tell me that I'm wrong, but I do believe in interoperability and how it is. So that took another week. So in total, from what I understand this project with experts would take about a month. Okay? A novice would probably take about 6 months because unless you're a mechanical engineer that knows CATIA takes about 2 weeks to learn, maybe 3 to be effective, right? Cameo, you can learn it in a week, but to be effective, probably a month. So it depends on your expertise level and your willingness to grow. Really, I can't put a true time on it, but I would say a 6 months, you could probably get to this.
what about the engineers that will work with the solutions? Because as far as I understood, all are these technicals with your tool.
Yeah, but so when we look at how it's all working, so let me ask you a question back so that I make sure that the answer is correct. So I've answered it to what I think is the right answer, but I want to answer it differently. So if you don't have a CATIA expert, and let's just say you have a SolidWorks expert or a Creo expert. Are they just as efficient at it? I just want the BOM of the part, right? Just the bill of material. The solution reads the BOM, and my job there is just to connect it, right? How do I visualize it? How does it fit into my system? And then make sure it talks all the way back to Cameo, right? Or the TMH. That person has whatever experience they have, right? But they can give me the part. When we talk about the meshing farther down, the Delmia side, which is the manufacturing, you have to have those experts. How big is the team? I don't have that answer for this. So you got me there. You good upright. But when we look at each level of engineering expertise, you have to look at your teams. You have your systems teams made up between 5 and 50, or large programs, you have 500, right? Mid-sized programs, you have 100 systems and software engineers. Okay, so look at that decomposition. Then you say, okay, how many CAD engineers do I need? What are their capabilities and functions, so on and so forth, and go from there. So, but bringing it all together, tell me a solution in the world that can actually bring all of that into one house, into one common data model. I only know of one. Unfortunately, it's ours. And the reason I can say that is because of our way that we can read data into the tools and distribute that data to be connected. That federated data model is a very successful capability that we as a SO have. Now, are some of our tools outside of our cloud deployment? Yes, they are, but they're connected. I'm feeding the cloud the data to show what I'm showing, right? Those individual parts, those individual capabilities are still there. The architecture might be out. Some of the requirement execution or embedded systems design might be outside. But when the data comes in, it's all federated, giving you, the user, the deeper understanding of what's necessary, right? So if I look at that particular bomb, wherever it comes from, whoever built it, I now can then trace it back to everything else. The goal of this is to really show end-to-end traceability, utilizing multiple solutions, whether it's Dassault solutions or not. My goal is to bring that data in, federate it, and make sure I can go through the manufacturing process for what? Launch and maintenance, and then look at that data on a consistent basis. Does that make sense? All in all, it takes an army. No pun intended. We define that army, meaning us as the engineer. Yes? Yeah. 2 minutes. Mm-hmm. I have stakeholders as well. Yes. So I have systems engineers that work for me directly. Yes. But I work with mechanical, electrical engineers. I have an electrical engineer on my team. I have software engineers on my team because we support the model-based systems engineering approach of systems engineering, right? But we feel at Dassault Systems that electrical is part of a pathway of systems engineering. We also feel software is the same, right? We can generate code now, and those can execute toward that side for the embedded side of the world because everything's becoming smaller, quicker, better, right? Embedded becomes very important. Then I work with the mechanical engineers. I work with the other downstream capabilities because they're outside of my tool realm. So it enhances and shows you of the collaboration between those domains and becomes very effective in that message of how it should or could be done with what you're trying to accomplish. Does that make sense? Okay. So that is really what I wanted to show. I didn't want to get into the electrical too much or show you some of the stuff that I'm not good at, right? I want to really just show that it's all connected and it provoked thought and 2 really good questions. So for me, I want to say thank you. I know as a speaker you're not supposed to, but it has been an honor to come here, fly from very far away, and for you to acknowledge that I'm trying to show you a path to success with solutions from our company, Dassault Systems. And I truly believe in it, right? I come from an acquisition, again. I'm a modeler by trade. And for me, to bring it all together and to show, and this end part really kind of sums it up, I believe in these solutions, and I've seen them be extremely successful, both in the military, both non-military, and even all the way down to a healthcare system. I'm not standing here in front of you today, I'll be super honest, without what we call growth markets, which is healthcare, automotive, high-tech things, because I won them just as much as I won with A&D. And so it shows that we can do everything and we can pull it together from a systems engineering perspective. The message today is about systems engineering and MBSE. I believe I conveyed that as best I could, but really showing you the options of how you can be successful when you adopt these types of tools within your environment. So with that, I say thank you. Hopefully you invite me again. I'll take the 9.5-hour trip anytime. And from there, we'll talk about something that you want, even in more depth next time from there. But thank you so much, and I appreciate it.
Thank you very much, Jason, for your presentation. Ahora vamos a tener unas palabras finales, ¿le parece? De cierre, vamos a invitar a Cristian, a Ricardo, ¿sí? Para que nos puedan acompañar y vamos a hacer, les pido hacer una reflexión final y los énfasis, ¿no? que les parece respecto de lo que ha sido la presentación de Jason el día de hoy. Yo los acompaño ahí, sentémonos si quieren, pongámonos como aquí y aprovechamos desde este espacio, ¿no? De hacer comentarios finales. Si quieres partimos con Ricardo. Si hay preguntas también.
Aprovecho para saludarlos a todos con los que no he tenido oportunidad de hablar y muchas gracias por la presencia aquí hoy. Como comentario final, les quería contar mi motivación personal para tratar de estar acá. Nosotros somos una empresa de servicios. Nosotros trabajamos en proyectos de ingeniería principalmente en Latinoamérica, pero también en otras partes del mundo. Y hemos participado en proyectos de $2.000, de $2 millones y de $2.000 millones. Y hemos visto en esos proyectos que una constante a través del tiempo ha sido el desvío de los presupuestos, de los tiempos de ejecución y muchas veces que no se ha alcanzado la calidad esperada y que no se han cumplido los requerimientos. Cuando uno mira para atrás, por qué pasó lo que pasó en proyectos de toda índole y de toda envergadura, uno empieza a rastrear un montón de problemas que podrían haberse evitado con otras metodologías. Hace 20 años que estamos como empresa de servicios haciendo esto y estamos viendo que en algunos lugares las cosas están cambiando. Entonces la pregunta que se nos suscita es, ¿qué fue lo que cambió? ¿Qué es lo que están haciendo distinto? ¿Por qué nosotros seguimos teniendo los mismos problemas y los mismos proyectos desviados en Latinoamérica y no nos está pasando lo mismo en los proyectos que estamos ejecutando en Estados Unidos o en Europa? ¿Son las herramientas? Las herramientas son hoy casi un commodity, podríamos decir. Están al acceso de todos. Proyectos de esa envergadura las pueden financiar. No son las herramientas la diferencia. La diferencia que tenemos esencialmente es cómo las usamos o qué herramientas usamos para qué. O sea, es una cuestión de recurso humano. Y como la diferencia que tenemos es en recurso humano, nos parecía sumamente interesante tener esta oportunidad de reunir este escenario, reunir gente de la academia, reunir gente de la industria y tratar de empezar a pensar juntos cómo realizamos un compromiso de mediano y largo plazo para poder generar en nuestra geografía los recursos humanos necesarios para cambiar la manera de hacer las cosas y cerrar la brecha tecnológica que muchas veces es una brecha cultural más que de la tecnología que estamos utilizando. Entonces esa es mi reflexión final respecto de esto, lo que me gustaría dejarles como desafío de que esto no sea un hito de un seminario interesante, sino que realmente busquemos una agenda de trabajo para ver cómo lograr ir en esa dirección.
Bueno, también agradecerles la presencia acá y una reflexión con respecto, quizá aprovechando un poco las preguntas que hiciste, Lino, respecto a cuánto tiempo se demora, ¿cierto? Cómo abordar un proyecto. Y esto pasa más allá de la herramienta, ¿cierto? O del software. Y cuando nos invitaron a participar en la Fuerza Aérea, y nuevamente agradezco esa invitación que nos hizo algunos meses atrás, el objetivo nuestro es ser parte de un ecosistema que conecta a la academia, que es un proyecto para nosotros a largo plazo. No estamos pensando en algo transaccional, no es algo de venir y vender una herramienta o un software, y lo digo abiertamente porque nosotros somos una empresa que vende software. ¿Okay? Sin embargo, tenemos estos programas que nos permiten poder hacer un trabajo colaborativo en el tiempo. Nosotros ya participamos en 2 o 3 instancias con ustedes. Por ahí capaz que hubo caras conocidas. Estuvimos en el National Payload hace algunas semanas atrás. La semana pasada también tuvimos ahí en una actividad en el Congreso de Santiago. Y la idea nuestra es seguir participando y poder de alguna forma ir trayendo el conocimiento que nosotros tenemos, el conocimiento que hemos adquirido en nuestras geografías, en nuestros clientes. Jason es la primera, no solo la primera vez que está en Chile, es la primera vez que está en Latinoamérica. Entonces, además, para nosotros también es un hito que conectarnos con gente que tiene esta experiencia a nivel global y traer ese conocimiento. Y por eso dije al principio, siéntanse con la libertad de hacer todas las preguntas, y la verdad es que agradezco, fue muy interactiva la audiencia, la verdad es que se agradece, pues, hubo mucha interacción, y eso permite también poder ir entendiendo cuáles son las necesidades o cuáles son las prioridades, o al menos sacando alguna duda que aprovechando que tenemos a nuestro especialista acá. Como dijo Jason, y voy a cobrarle las palabras, Jason no va a ser la última vez que va a estar. Hay un equipo bien más grande también en el cual reporta Jason, que puede también participar en algunas actividades posteriores. Pero solo resumiendo, creo que es súper importante tener esta ecuación donde está la academia, donde está la industria, donde está la Fuerza Aérea, en este caso, ¿cierto? Y ese grupo, digamos, que se tiene que transformar en un círculo virtuoso de ir adquiriendo y conociendo experiencias que estamos teniendo en otro lado. Por mi parte, dejar súper abierta la invitación. Esto no termina acá. Yo esperaría, y ojalá ocurra, que nos empecemos a interactuar en los siguientes días, las siguientes semanas, porque van a salir dudas, van a salir preguntas. Y solo voy a terminar acá mi comentario, y nuevamente voy a ocupar tu ejemplo, Lino. Es nosotros, en cualquier tipo de estos proyectos donde a lo mejor hay algunos gaps de conocimiento que pueden existir, tratamos de acompañarlos y con especialistas nuestros en alguna parte de la geografía, con partners con conocimiento, acompañarlos de tal forma que vayan aprendiendo junto con nosotros, para que después los siguientes proyectos ya empiecen a volar solos. Así que no se sientan tampoco, quizás esto está un poco lejos, no. Es como los acompañamos para que en un futuro mediano ya sean totalmente autosuficientes en este tipo de tecnología. Eso por mi parte.
Bien, muchísimas gracias a ambos, a Ricardo y a Cristian. Yo solo quedar con algunas reflexiones finales respecto, primero, lo importante que es construir propósitos, ¿no? País, cuando en el día a día vemos tanta cosa contingente que nos distrae de lo realmente significativo, ¿no? Temas como Hermosilla, ¿no? Temas de seguridad, que a veces en el corto plazo nos consume una cantidad significativa de tiempo, más que pensar en cuáles son los grandes desafíos que tiene el país. Hemos perdido por muchas décadas una agenda transformadora significativa, y creo que lo primero que nos debería llevar a reflexión es cómo todos contribuimos en armar estas agendas de transformación. Yo creo que en torno, ¿no?, al plan satelital, al desarrollo, ¿no?, de esta oportunidad que tenemos en el espacio, y convertirlo en una palanca de crecimiento y desarrollo, ahí tenemos un tremendo desafío muy importante. Segundo, además de la construcción de propósitos, es que los problemas que se nos vienen, ninguno de ellos es simple. Los problemas simples, como dice un amigo, se acabaron. Quedan puros problemas complejos. Y dada la complejidad creciente que tenemos que abordar, es necesario una nueva mirada desde las ingenierías, una nueva mirada desde la filosofía, desde las artes liberales, pues necesitamos capital humano. Y desde ese punto de vista, entonces, las arquitecturas son una respuesta a cómo deberíamos diseñar estas distintas componentes en sistemas que por una parte son crecientemente complejos, pero que desde el punto de vista de la usabilidad queremos que sean como el reloj digital o el celular, simples de entender, simples de operar, diseñados para el usuario del día a día. Ese es un desafío de la ingeniería y por lo tanto la presentación de hoy día nos permite conectar propósito, estrategia, con una mirada de las arquitecturas y de las componentes, ¿no?, de la ingeniería desde el diseño a la ejecución y adicionalmente con los recursos. Y no olvidarnos que mencionamos recursos que son tremendamente relevantes para la transformación. Los datos. Los datos son un activo estratégico. Sí, solo sí, somos capaces de modelarlos y utilizarlos para mejorar la capacidad de toma de decisiones. ¿Sí? Que puede ser mejorar la operación de un hospital, mejorar la operación, ¿no?, de un sistema que está ayudando, ¿no?, a combatir incendios o apoyando a nuestros chilenos ciudadanos, ¿no?, que están en partes alejadas del país. Los datos como el primer elemento y la ciencia de datos para poder usarlos adecuadamente. Segundo, la agilidad organizacional. Porque detrás de esta modularidad, de esta ingeniería, es la capacidad de tener organizaciones que sean crecientemente como Lego, ¿no?, que las podemos configurar y responder a distintos desafíos. Y por lo tanto necesitamos estas componentes y esta arquitectura que nos permita, ¿no?, rápidamente deconstruir, reconstruir, habilitar el capital humano, que lo mencionamos aquí, más allá de las competencias específicas y técnicas que se requieren un nuevo estilo de liderazgo, una nueva capacidad de orquestación, se requiere la capacidad de trabajar con ecosistemas abiertos, se requiere capacidad de construir propiedad intelectual, como veíamos, muchos activos intangibles que tienen lógicas distintas a los activos tangibles, ¿no? Estamos entrando en un mundo que tiene estas características desde el sentido de propósito, la construcción de un nuevo tipo de arquitecturas y de ingenierías integrales y además una gestión activa de un conjunto de recursos. Si esto me lo hubieran contado a mí hace 40 años atrás, cuando empecé a estudiar ingeniería, por supuesto que me habría parecido muy, muy desafiante. Bueno, hoy día estamos en esa vuelta de ciclo donde es necesario repensar, transformar, así que nada, invitarlos a cada uno de ustedes que sean también agentes de cambio y se sumen, como bien decía Cristian, como decía Ricardo, activamente a este proceso de transformación, construir desafíos en esta oportunidad en torno, ¿no?, a la oportunidad que el aire y el espacio nos permite formar capital humano, que da gusto ver también gente joven aquí, por supuesto, jugar un rol activo en transformar estas ideas en una realidad. Así que muchísimas gracias por habernos acompañado el día de hoy y esperamos a todos verlos muy prontamente. Y como dije, la Universidad Adolfo Ibáñez es su casa. ¿Y una pregunta? No. Por favor.
Yo soy Leopoldo Porras de ENAER. Y en ENAER nosotros estamos usando esta herramienta. La verdad que todavía no somos expertos en ella. Tenemos CATIA de hace muchos años, pero ahora sumamos el 3D Experience. Cuando Jason puso aquí una fotografía de dibujantes en unos paneles y uno XT, que yo creo que ustedes no conocen los XT, pero yo conocí los XT, yo soy de esa época, de los que diseñamos con paneles y con XT. De esa época soy yo, es decir, de la época del 80. Hay una diferencia enorme entre lo que nosotros hacíamos y trabajábamos en diseño del avión Pillan 1 o las modificaciones del avión F5 o la modificación del avión Mirage a lo que realmente están haciendo el día de hoy. Y discrepo un poco con lo que tú dijiste al principio. El commodity, que es el CATIA 3D Experience, es importante. Y nosotros nos falta eso. Nuestra gente, ustedes, los que están estudiando, los ingenieros que están acá, son capaces de hacer esas cosas. Nosotros en ENAER adquirimos la herramienta, la colocamos en un grupo de ingenieros que son 30 ingenieros, muchos de ellos vienen de la Academia Politécnica Aeronáutica y de la Universidad de Concepción, que son ingenieros aeroespaciales. En estos momentos ellos están diseñando un avión, están diseñando alas, están trabajando con elementos finitos, están trabajando con túneles de vientos virtuales. hemos sido capaces de lo que nosotros nunca habíamos podido hacer antes. El ala del avión Pillán es un ala que fue diseñada en Piper. La fabricaban, la enviaban a Chile, nosotros la modificamos y la instalamos. El ala del avión Pillán es diseñada por nosotros. Y cuando digo nosotros, no estoy hablando en AER, estoy hablando con ingenieros chilenos. No trajimos ingenieros franceses, no trajimos ingenieros norteamericanos. No, son puros chilenos. Son todos muchachos que vienen de nuestras universidades, en la cual les dimos estas herramientas, que por supuesto que no somos expertos todavía. Todavía nos falta mucho que aprender. Pero hemos hecho cosas que estamos muy orgullosos, que no se hacen comúnmente acá en Chile. Uno las mira de otros países. Y ustedes que están generando estas iniciativas, y están generando unas nuevas carreras, generando muchachos que aprenden, necesitamos esa herramienta. Si tenemos esa herramienta, tenemos gente, líderes que generen proyectos, porque eso es lo que nos falta, que generar proyectos, inversión, para poder hacer cosas nuevas, nosotros podemos hacerlo. Necesitamos simplemente tener acceso, digamos, a este tipo de cosas. Así que los felicito porque la verdad es que con lo que ustedes hacen nos permite a nosotros desarrollar algo que el cual nosotros nos sentimos muy orgullosos. Y espero que los chilenos en general se sientan orgullosos. Muchas gracias.
Gracias. No sé si quieren agregar algo más. ¿No? Por mi parte no. Muy bien, pues muchísimas gracias a todos. Gracias por acompañarnos.